Hello. Good morning, madam.
Hello. Good morning to all. Good morning, sir. Shankar sir.
Good morning. Can you hear me?
Yes, sir. You are audible.
Okay, fine. I'm loading.
Sir, are you ready? মানে আপনি রেডি হলে বলবেন। ওকে স্যার, আপনি রেডি হলে বলবেন। আর পল্লব, হোয়াট অ্যাবাউট দ্য স্ট্রিমিং কখন স্টার্ট হবে সেটাও বলো। হ্যাঁ,
গুড মর্নিং ম্যাডাম, সুধাংশু বলছি।
হ্যাঁ, গুড মর্নিং
ম্যাডাম, লাইভ স্ট্রিমিং ওকে আছে, শুরু করে দিতে পারেন।
আচ্ছা, তাহলে স্যার রেডি হলে উইল স্টার্ট। ওকে।
হ্যাঁ ম্যাডাম, চালু হয়ে গেছে।
ওকে।
Apple, Delhi, yellow, red. Calcutta, Fort. Fort.
Good morning.
Good morning, sir. Good morning to all the participants, our respected Dean R&D, faculty and staff of Electrical Engineering Department of Naval Institute of Technology. Welcome to the day 5 of short-term training program of recent trends in application of IoT and condition monitoring for distributed generation. So today our distinguished speaker is Mr. Shankar Mukhopadhyay. Let me take a few moments of reading out his profile in brief. Mr. Mukhopadhyay is a graduate in electrical engineering of Jadavpur University in 1983, and he has 36 years in power sector in GEC, Tata Power and CSC Limited. He has worked in operation and maintenance of both generation and distribution sector. He has worked in power system operations, load flow and load planning and commercial functions in power business. Since the last 10 years, he is heading the Asia Institute of Power Management and Consulting ASC, and expanded the institute with all India repute, having clientele from all parts of India and abroad. He has proven expertise in business development related to power and energy sector. He is a chartered engineer of the European Council, the chairman of the Institute of Engineers and Technologists, and energy auditor. He has also worked with renewable energy and passionate on sustainability. So now the session is all yours, sir. If you are ready, you may start your lecture.
This is something new to me in the new normal scenario. Earlier, whenever I had give my dissertation lectures, I used to see the faces of the participants, and it makes me, more jubilant. While seeing their faces, I could understand that what is their queries, and where should I, stop or should I expand. But this is something, I need to see the faces of all the listeners. Basically, imagining their facial expression. So if you get bored, you please write a post that you are not enjoying. I'll try to, deviate from that topic, or I'll try to modify. Anyway, this is just the beginning, and let me start my dissertation. First of all, I thank JIS and Naumita to call me here. I do not belong to academic discipline, and I am not expert of this IoT topics, but as I have been working long with power sector, I can share the development of power sector and the present requirement of IoT related activities in the ongoing power scenario. The world and the India as well, both are changing their working styles. In every aspect, India is little bit lagging behind, but trying to cope up with the present progress. And we are now trying to develop ourselves from the status of developing to fast developing, right? And let me start with industrial revolutions. As you know, that industrial revolutions can be divided into 4 phases. In the first revolution, new sources of energy were discovered to run the machines. The mass extraction of coal and the invention of steam power plants were significant development stages in this phase. The second revolution, known as mass production of electricity generation, was a period of rapid development in industry, distinguished by large-scale iron and steel production. That was the construction period. That is the level when man-made energy, human energy, got transferred to machine energies. During this phase, many large-scale factories with their assembly lines were established and formed new businesses. The third revolution introduced computer and first generation of communication technology, which is little bit prevailing in India right now, with the advancement of telephone system, which enabled automation in supply chains. But the present day of development, which is the level of transition, a large variety of modern technologies such as communication engineering, communication system, intelligent robots, and the Internet of Things, IoT, are striving for the 4th industrial revolution. By allowing them, people, data, and processes are right now combined together. IoT can help improving different processes to be more quantifiable and measurable by collecting and processing large amount of data. You all know this. IoT can potentially enhance the quality of life in different aspects basically in service sector and in electricity services as well, which is manifested in smart grid activities. This is enabled by providing an increased automated decision making in real time and facilitating tools for optimizing such decisions. India is now at the process of transition. She has to increase the use of energy, but having deep shortage of resources. So the challenge is to have more efficient use of energy. This is number one. As we are having, shortage of resources, how we can manage with the growth. You must appreciate that we should be more and more efficient in usage of energy. And number two, harnessing natural resources, naturally available energies, which is not detrimental to the society. I will gradually come to this level. At this backdrop, we start the discussion with a brief snapshot of India's energy scenario and the possible development with distributed energy and IoT-based smarter applications. So I'm starting with the main slide, first slide. It is showing our present network or present electrical grid, where you see all. Can you see the presentation? Is it visible?
No, sir, till now it is not visible. Now it is coming.
Okay.
Hello, sir, one thing more. Hello.
Yes.
Sir, one thing more. The participants are there in the YouTube and they will write the questions in the chat box and that will be conveyed to you after your lecture is over. Okay, sir?
Okay. Thank you so much.
Okay.
Now, I want to give a brief synopsis of the energy baskets in India. Let us have, I presume all of us, the listeners are Indian, so let us have an idea, a brief idea of India's energy scenario. Let me start with the area of India. That is 32,87,240 square kilometers is the area. And population is around 1.37 billion. Our target is to become a 5 trillion economy. Regarding energy consumption, mainly electricity, India is the third biggest after USA and China. Our per capita energy consumption is 24 gigajoule. I'm talking about the entire energy basket, not confining only in electricity right now. And the world's per capita energy consumption is 76 gigajoule. That means we are consuming almost 1/3 of the energy requirement by the world. We have to grow up from this level because we need to grow. We need to become a 5 trillion economy. And India's energy resources baskets is that coal is 56%, crude oil 30%, natural gas 6%, nuclear 1%, hydro 4%, and renewable 3%. India import 200 plus million ton of crude, about 80% of total demand, 30 million ton of liquid natural gas, and owns 40 million ton of coal, which is about 45% of total energy and spend. You can just imagine what the quantum may be, 10,000 billion Indian rupees. So, to remain energy sufficient and just to meet the energy requirement in India, we spend so much. And now, if I go to the electricity field, you can see that how much we have grown. In 1947, when India got independence, our installed capacity was 1362 megawatt, and now we are generating, we have an installed capacity of 371.8 gigawatt. That means 3,71,000 megawatt. That means it's a very steep rise which we have done after independence. So we are growing, particularly in electrical scenario. Today, if we talk about Indian power sector, I spoke you that India, this is the third largest global power producer and consumer. India is the third largest producer and consumer of electricity of the world, with the installed power capacity of 371 by May 2020. The country also has the fifth largest installed wind capacity in the world. Still, we have many miles to go. We have large expansion plans, investment from the government under various schemes to reduce ATC losses. I will come to these ATC losses in due course, but just keep in mind that as we want to be more energy sufficient sustainable in India, if we want to have more per capita energy usage, then we have to reduce the energy losses because it is reducing our overall efficiency. We need to improve technical and commercial functioning of power sector. The government has invested a lot in 24/7 power for all. You must have heard that this project is on. Developing smart cities as what? Why we intend to develop smart cities? Because we want to reduce losses. We want to make systems to move much faster and making smart power infrastructure for the same reason so that decisions can be taken instantaneously and the customers who are paying a bulk amount for electricity bills, they should not have any pain in getting quality electric power. We need 100% 100% completion of rural electricity supply and giving electricity access to all, for which the government is continuously spending. We want to have robust growth in renewables and distribution generation. Wind energy is estimated to contribute 60 gigawatt, following by solar power at 100 gigawatt by 2022. The target for renewable energy has been increased 175 gigawatt by 2022, and again it has increased further to 275 gigawatt by 2027. Favorable policy for environment. The government has allowed 100% foreign direct investment under automatic route in the power segment and for installation of renewable energy. New amendments of Electricity Act 2003 is still on the anvil on RE policy and cost reflective tariff. So the government is investing from herself. The government is trying to bring foreign investment for environmental improvement, and the government is continually trying to boost efficiency so that the per capita consumption can be increased. Now, right now I will try to explain you the figure of Indian electrical scenario. For the ease of operation, India, as you know, it's such a big country, 32 lakh, more than 32 lakh square kilometer area. So you cannot imagine like a small village or small city, the networks will operate. So for the ease of operation, the country has been distributed in 5 regional grids, and all the grids are connected. So the name of the grids are, if you see from the north, this is the northern grid, which is comprising of various states, northern grids. Then the eastern grid, you see the eastern region, the eastern grid, the western grid, and the southern grid. And one for the 7 sister states, that is the northeastern, there is a small grid also, northeastern grid. Now the grids are having some peculiarity. What is that? As you see in the presentation, the northern grid is initially a deficit region, and it has got wide variety of atmosphere or the variety of climatic region. In the great north, you see the Kashmir and the Jammu and Kashmir. There are snow-fed run-of-the-river hydro, highly weather-sensitive loads. It also have the desert of Rajasthan, and so the industry-rich areas also there. The Haryana, Delhi region, the Rajasthan also has industries, and part of this northern UP and others where industries are available. So it has got both agricultural and industrial loads. The maximum load of this area is around 60 gigawatt. The minimum is 30 gigawatt, and average load you can presume it is of 40 gigawatt. The western region, which is more in industry based areas, it is comprising of Gujarat, Maharashtra, MP, and Chhattisgarh. Their peculiarity is that long haulage of power from east to west, because I'll come to that. It has got industrial rich areas. It has got good amount of loads. So the demand, maximum demand is 55 gigawatt, minimum is 38, and on an average, this is 45. Then we talk about southern region. It was earlier a deficit region. Right now, it has become almost self-sufficient. It has got high agricultural load and reasonably good industrial loads. Its maximum demand is 45 megawatt, a gigawatt, minimum 25, and average 35. And lastly, we talk about the, not last, the fourth one is eastern region. It is not having much of load, but it is resource-rich areas. The resource-rich areas are eastern region and part of western region. So, as it is a resource-rich areas, you can presume that most the thermal generating stations will be placed here, and from the generation to the load side, the current direction or the power direction will try to flow. So you can presume that the load flow will take place from the eastern region to the western region and eastern region to the northern region. Previously, there was also a load flow from eastern region to southern region, but right now, as I told, that southern region has become more or less self-sufficient, so there will be less flow from the eastern region to the southern region. And the last one is northeastern grid. As you know that the northeastern doesn't have much of industries, mostly forest areas and rural areas. The maximum load is 3 gigawatt. Minimum in winter it is 1 gigawatt and average is 2 gigawatt. And the peculiarity of northeastern to other regions is that They have got good amount of hydro potential, but bringing that hydropower from northeastern to eastern is difficult. But because only through a very narrow region, Chicken Lake, this northeastern connected to the rest part of India. So if you go to particularly these areas, Aligarh and close to Bhutan, you see this Chicken Lake contains good amount of transmission lines from where power is coming from Bhutan or even from the northeastern to India. This is basically a NASA picture, which is quite interesting to see, which identifies through illumination that which are industrially rich areas. You can find that brighter illuminations indicates those areas who are industrially or those who have got good amount of urban locality. The peculiarity of India, as I told you, that skewed resource distribution. So it requires long haulage of power from where resources more, power generation is more. So from power generation area to load area, this good amount of power has to be transmitted, that we call long haulage of power. Resource inadequacy, the resources are not uniformly distributed, and we have got weather extremes. We have got Assam continuously raining, and you see again nowadays flood has been cropped up in Assam. Assam, Guwahati is getting inundated, and we have got Rajasthan also. So good amount of diversity. I told you we have got a generation strength of 371.9 gigawatt. The breakup is here, you can see. Thermal is still the leading, then hydro 45.7. We have only 6.8 nuclear. Solar is 35.3, wind is 38. So totaling solar and wind, we have got almost even less than 80 megawatt, 75, close to 75 megawatt. We have got both solar and wind. We have a small hydro. If you take that into account, it will cross 80. And we have miscellaneous. These are basically biofuels and others. So these are 10.1 as a whole. This is 371.9. Now this, I was talking about the resources. The resources means I'm showing you the energy map, which identifies the resources. In the extreme right, you can see the coal resource, which is indicated by black patches. And you can see the coal reserve is about 101 billion. India is the fifth largest in coal reserve. And this 101 is a very conservative estimation. We have got much more than 101, but considering the forest reserve and the difficulty in mining, we have taken this figure. So considering the present RP, that is reserve versus production RP ratio, we expect it to last about more than 100 years. The mines are in Jharkhand, Madhya Pradesh, West Bengal, Odisha, and in Maharashtra. The solar potential in India is high, but there are, in fact, in the globe, if you see the solar potential, there are also higher potentials in India. The highest solar potential is available in India, maybe in Ladakh areas, where the temperature is low and the cleanliness is very high, so the solar luminescence is pretty high. So you can expect a much big quantum of solar generation from there. However, more or less, it is equally distributed, little more distributed in the western part of India, but more or less evenly distributed all over the India, rather less distributed in the West Bengal region. But you can see the lines that in India, the solar energy available in a single year exceeds the possible energy output of all the fossil fuel energy reserves. So we need to harness more and more solar. And accordingly, the government has taken a decision to install a huge quantum of solar generation and integrating the entire power system. The wind power potential in India is 302 gigawatt at 100 meter or 103 gigawatt at 80 meter. I'm explaining what is this 302 at 100 meter and 103 at 80 meter. What happens that wind turbine when moves, it takes the help of wind speed. And as you know, when you move up from the ground level to the at a higher level, the wind speed increases. So at 50-meter level, wind speed, which is for the low height wind turbines at 50 meter, what happens that the speed is so that you can get a generation of total in total India is around 50 gigawatt, but we are very close to that. So right now 50 gigawatt is not sufficient for us. So we are thinking of putting the turbine at a higher level, and a survey of the entire wind map reveals that we have a capacity of 103 gigawatt if we make the next turbines at 80 meter, and much more, almost 3 times more, if we can increase its height, it's another 20. So the engineers are right now working for having wind turbines at a much higher level. This is basically, I am trying to show you the power evacuation network of India. You see the central ring, which is basically of 765 kV transmission lines, which is making a ring network, and from the pink arrows, which is directed towards this ring, basically coming from the resource-rich areas, they are putting power into the ring, which can be considered as a bus bar. And from there, the blue arrows, who are directed towards outwards from the ring, which are feeding the load reaching. This is basically conceived India's one very, very high transmission line capacity. And another blue line you are seeing, which is the green corridor, which is being set up under the process of setup for the renewable generation. So renewable generation, we are right now talking about, our topic is basically distributed generation. Now, what is distributed generation? Distributed generation per se, it is a renewable generation, but not in bulk quantum. Renewable generation in small quantum, which is again coming as with a new concept of making a consumer to a different category, that the consumer will term as a prosumer, because while taking power from the grid, he is also having the capacity of generating power. He will be a producer and a consumer as well. So his term has been changed from consumer to prosumer. These will happen in distributed generation, and that will make, basically paradigm shift in the entire power scenario. I will gradually come to that. So it is clear to you that in India, the transmission network, this power is coming from load-rich areas where generating companies are more, and they are going to feed the grid, and from the grid, power is getting emanated to the load-rich area. So this is basically the transmission lines are set with this concept. Now you can see the flow lines of powers. Again, what I told, this is basically depicted in this picture, not much to explain. You can well understand that from where to where the powers are moving. I'm changing the slide. Now, Indian power sector, the bare necessity. What is that? Growth of Indian economy is on the medium track. I am not talking about this year, because after COVID and even before COVID, the Indian entire economy was not in a favorable condition. Particularly in the last year, the GDP has fallen because of low industrial product, and there is, in fact, if you go through the global economy, there was a global recession. So everywhere the economy was not doing, has not done well, and we have also not done well. And after this January onward, that is the onset of this new year, with this COVID, the entire economy is in shambles. So you can well understand that now whatever I am talking about 2019, and whatever I am foreseeing from 2021 onward, that presuming the COVID scenario will be over by the beginning of the next year. So let us not keep a mental taboo on today's incident, because we must consider this as an exception. An exception doesn't really prove the rule. So growth rate of Indian economy is on the medium track. We can presume that hinges on its ability to provide electricity, need to elevate the living standard, sustain economic activities, and improve productivity. So these three things are very important. So need to elevate living standard, because elevation of living standard means more usage of electricity. This is number one. And number two, elevation of living standard depends only when people have sufficient money to procure electricity and to buy more and more gadgets so that they can use more electricity. So they have to have a good amount of income too. That should happen only when if industrial activities begins at a much faster level. Now we can think that the Prime Minister has spoken about this Atmanirbhar Bharat, which if really takes place, then the scenario will be different. Per capita electricity in India today is 1181, that is even less than 1200, which is 1/3 of the world average. This is true. I talked about energy average, and again right now I'm talking about, which you saw that out of around 1/3 of the gigajoule energy which people per capita energy consumption was there, and today we see that 26 gigajoule and whatever we are consuming electricity, which is again world average, if you can see, close to 3,126, we are consuming less than 1,200, which is again about 1/3 of the world energy. This is basically a picture collected from the Wikipedia. You can also find out that what is the global average, what is the country-wise average, and if we think about China, it has crossed 4,475. United States, Canada, I am not talking about them because they are basically based in cold region. They have got less manpower. They have got enough resources, so they can spend more. But we people should spend more electricity, not to waste electricity, but to put it in a productive form. So we need to increase electricity consumption. Now, India's energy challenge. India's energy challenge is basically things that growing electricity demand, creating pan-India market for renewable. What is today's problem? We are bringing more renewable. What is today's problem? We are having less demand, so we need to grow more electrical demand. Another thing is that India's international declaration under climate change seeks 40% of electricity installed capacity will be non-fossil fuel by 2030. Let me talk something on that. India is yet to achieve universal electricity access. We are talking about growth. We are talking about people empowerment. We are talking about more electricity consumption by the consumers. But today, the sad thing is that even electricity is not accessed by few of our countrymen. And the government has given due priority on making electricity for all, access to electricity for all. In my first slide, I told you, second slide most probably, I told you that the government is working very hard and we have given access to all the villages. But electrifying only one house of a village does not mean giving access to electricity to all of the countrymen. So, the program is right now to reach electricity to every household. That means every consumer. If we have got 138 crore number of countrymen, then if you assume that almost there are in every family there are 4 members on an average, then 138 by 4, that means almost 35 crore consumers are available in India, and you have to give access to them. But still, 1-2 crores, probably, I am not very sure, do not have access to electricity. And another is security problem. That is, India is dependent on oil import for 80% of its demand. So, with electricity, if we can reduce some of more electrical energy, if we can supplement some of the oil energy, that will also be good for economy, where we are spending every year 10,000 billion dollars, 10,000 billion rupees. Imagine the figure, 100 million. I mean, basically 1 billion stands for a very, very big amount. You know that 1 billion is 1,000 million. That means 100 crore. So imagine what a big amount. So our demand is one area, renewable generation is another area, access to electricity is another area, security of energy is another area, and climate change is also another important area. And I'm telling you some of the small write-up on this. The global electricity demand rose at a CAGR of 2.5 to 3% till from 2010 to 2018. I am speaking on this climate change. As thermal being the primary resources, CO2 emissions increased substantially. You know that in India, even today, thermal is the prime generation. This CO2 emissions is threatening the world towards extinction if the temperature rise cannot be checked beyond 1.5 degrees centigrade. Thus, by the thermal generation is developing greenhouse gas and thereby increasing the temperature. If you even today or any day, if you open related if you see discovery, you will find that the polar region, the icebergs are getting cracked, the melting of icebergs, and because of the temperature rise. So the global planet is the verge of extinction. And the global warming, if it exceeds by 2 degrees centigrade, we are going to face a very bad situation. Many of the places in India will get inundated by the rise of seawater. These are very alarming scenarios. So these will have a severe impact on the planet and human life. The environmental concerns such as global warming and local air pollution, scarcity of water resources for thermal power generation, and the limitation of depleting fossil energy resources raise an urgent need for more efficient use of energy and the use of renewable energy resources. So energy efficiency, I told you, one of the key drivers of sustainable development. Moreover, energy efficiency offers economic benefits in the long term by reducing the cost of fuel imports, supply, energy generation, and reducing emission from the energy sector. The energy supply chain includes 3 major parts. Firstly, energy supply includes generation from renewable energy resources with reduced and efficient generation from traditional system, because we cannot stop traditional system. What we can do, we can make traditional systems a more healthier system. We can't stop releasing CO2, but we can make better efficient. That means per unit of coal, the output energy can be more. So efficiency improves. I'm telling you from the earlier, this pulverized fuel boiler, when we are talking about supercritical boilers, that is some subcritical to supercritical, when you are elevating, we are basically increasing the efficiency. From a 40 megawatt, 60 megawatt generating stations, when we are increasing it to 500 megawatt, that is the economy of scale, we are improving the efficiency. So these are the objectives, how we must improve efficiency. At the same time, we will harness installation of renewable powers. May it be in bulk form, may it be in distributed generation, and I find distributed generation is more economic than bulk generation of renewables, because in every bulk generation, although you are generating in bulk, you are doing what? You are, upgrading it, you are utilizing first inverter, you are utilizing then transformer, you are stepping up the voltage, you are transmitting the power, again you are stepping it down. So every conversion you are using, basically technical loss is getting incurred, you are using some amount of energy in your system. Now coming back to our presentation, the Paris COP21, which has happened in 2015, India had made a commitment in Paris Climate Agreement to reduce emission intensity of the economy and having at least 40% of electric power installed capacity from clean energy sources by the year 2030. So we are working on a very steep target. We have got two focus. One is we must be in line with the global objective of mitigating CO2 release. At the same time, we are also trying to enhance our renewable generation to supplement even import of coal, import of oil, so that we can get a little respite to our economy, right? These are the breakers. And accordingly, we are increasing the installed capacity. In 2017, the entire installed capacity was 2017. The renewable was 18%. 2019, the renewables increased to 23%. Thermal was 66%. The thermal has been reduced to 63%. The nuclear, we are a bit conservative about nuclear. Because of various reasons, we don't have nuclear resources. We have to bank on other countries also, and we know the experience of Fukushima, Chernobyl. So still we are little bit skeptic on installing nuclear, but I think in future, to mitigate carbon dioxide and to have a stable power generation, we may have to increase more nuclear. Now, growth of renewable and solar capacity in India, I expressed you that this increasing is very fast. Basically, we are exponentially increasing this renewable generation. We are exponentially increasing the renewable generation. Again, this is a chart, sector-wise renewables as on 1/1/2020. This is wind power. Still, wind power is little more than solar power. We are in solar power, we are little bit less. This is small hydro. The figures are there. Cumulative as on 31/12/2019, that's first of 2020. And the biopower, this is almost 10 gigawatt, and the waste to energy, which is really very small. It is not that very economic, and getting resources also very difficult. But if we can be more, selective on waste, segregation of waste, the waste to power can also be a good input in our distributed generation. Why? Because this is, easily available in city areas, and many of the waste we do not see clearly. Many of the waste contain good amount of calorific values too. So if you can burn this calorific value rich waste to heat energy, and produce electricity through combined cycle gas turbines, so they can give some amount of good energy. And waste, anyway, you need to get rid of this by a method of disposal. Either it will release stinking odors, or it will make your roads or areas, locations, spoil some areas with its, what should I say, with its nasty appearance and odors. So this is basically a good quantum for making energy. May not be, it can be produced in bulk, but it is good for the society. So waste to power, I also tell the participants to take care of that if something can be done. Now wind power achieved latest is that 37 gigawatt. Solar power latest is 31.379, but some quantum of rooftop is not added here. Solar power, the rooftop is 2.3 gigawatt, but it is somewhat more. Small hydro 4.6 gigawatt. Biopower, I told you, almost 10 gigawatt, and waste to power is almost 139 megawatt. So in totality, the RE basket is around 86 gigawatt. One point I should say, that whenever we are producing something, because I have been coming from industries, and those who are with the academic discipline, your and our viewpoints are a little bit different. Whenever we think that whatever we are going to produce, whether it has got a market, can it be sold? And therefore, the competition comes, and with the steep competition, the cost of energy of solar has come down drastically. We started in the year 2010 as 17.91, and it has come down to rupees 2.44, but such a low price in solar may not be sustainable. This is also my apprehension. And accordingly, the hydro power, the wind power has also had a value of 3.12, and it has come down to 2.43. But such a cutthroat competition and such a low price tag may not be a sustainable one. Particularly right now, we are having some problems in bringing solar raw materials from China. So if we want to bring it from some other country, the prices will be more. If we intend to set up the factories in India, because we are planning to grow much in solar, the cost of solar cells will be more, and same with wind turbines. So the cost, but we need not to be very fussy about the cost, because in India the average sale price of a unit of power is almost 5 to 6 rupees. So what is the point of producing electricity at 2.43 when a customer buys it at 5 to 6? So if we can improve the quality, if we can make it more Indian, and the price goes up, I don't think that will much affect the customers. Only thing what we need to improve our service system, we need to improve our supply system. Installed wind capacity at states, this is just to show you that Tamil Nadu, because of its geographical position, it has got the highest capacity. It has got more than 9 gigawatt. Gujarat 7 gigawatt more than. Maharashtra almost 5 gigawatt. And so the West Bengal is not in the map, because West Bengal does not have wind potential, and we are also not much after this renewables. In fact, if you see solar, we don't figure in the pan India figure. If we see wind, we also don't figure. So I am also requesting those who are interested in renewables, they can also, if you have got something, interest of being an entrepreneur, or if you want to have some research activities, you can also see and try to find out what is the solar potential, how much you can do, can we do at all anything here, or not, that can be also a part of your activity. Small hydropower, again it is less than 25 megawatt. The potential 21 gigawatt. Achievement so far we have got 4.4 gigawatt. This is one interesting curve I am showing you. All India Wind and Solar Power Daily Generation Report. This report I have collected from our regional power center. Interesting thing is that you see the blue line is fluctuating grossly, and that is the wind power. So if we talk about the reliability of generation, wind power does not have that reliability. It is very, very fluctuating. And solar, in such cases, has a little more reliability, but the availability of solar power is also an issue. It is only available so long there is sunlight. In the half part of the day, you are having solar. So CUF, when we talk about capacity utilization factor of solar, is almost 16 to 18, maximum 20 to 22%. It starts with 16 and ends with 22%. That is, basically it is termed as a plant load factor. That is the maximum capacity, maximum rating into 24 hours throughout the day, how much energy is capable it can release, and the numerator is how much energy it is releasing in reality. That is real output divided by the possible output. Had it been operating 24 hours a day, what much it could have operated. It is for thermal generation, it is much easier. It is termed as plant load factor, because thermal generation, you can, if you can give load, it can run for 24 hours with the same efficiency. But for solar and hydro, as the prime movers are coming from a different source, in hydro, in solar and wind, in wind the prime mover is basically your the wind speed, which is fluctuating. So you do not have any prediction of its capability, of its generation ability. And for solar also, you don't have any control on the sunlight and the incidence of sunlight. There can be cloud, so the sunlight will be less. There can be, rain, so the sunlight will get affected. And if there is, for wintry areas, if there is smog or if there is fog, the sunlight will get affected. So you have got more or less, do not have much control on this. Again, for a part of this. So CUF, the capacity factor for wind and for sun solar generation, which is low. For solar, it is 16 to 22% maximum, and for wind, it is on an average 20 to 24%. This is another curve. I'm showing you the installed capacity mix the country in the year from the year 1980, and it indicates that the renewable share, the green one, is increasing. The nuclear is maintaining more or less a steady mark. The gas plus diesel, it is again reducing, and the coal plus ignite, it is again for the last few years, it is again reducing. One interesting point I will tell you, what I have already mentioned, that plant load factor, which is happening in thermal, with more and more usage of renewable and hydro, if I can say, which is also right now falling under the category of renewables. The thermal generation, which should be, and right now that is happening, it is reducing its plant load factor. That means its operating time is getting reduced. But keep one thing in mind, this is affecting the economy also. Because when a thermal plant was set, it was presumed that it will operate at a plant load factor of 78%. Now we are not allowing it to be more than 57%. So how a thermal generation can survive? You can say for the sake of environment, a thermal plant shouldn't survive. But keep it in mind that since we are operating with some unstable generations, which is wind and solar, we have to supplement the entire thing with some stable generation. Today we are not that much, banking on the storage system. We don't have good amount of pump storage. We don't have good amount of electrical storage, that is, battery bank. So we have to depend on thermal generation for a longer period. That's why I was emphasizing on having more efficient thermal generation than thermal generation with lesser efficiency. So this is the talk of today. As although we have reduced the performance, the plant load factor of thermal generation, the coal consumption has increased. Why it has increased? Because the quantum of energy output from thermal, because every year we are increasing almost 4% in energy, 3 to 4% in energy. So as the energy growth is continuous, the share of thermal generation is also increasing, although we are trying to reduce its plant load. That is, number of thermal generating stations has increased, so each and every other generating station is taking up somebody's share. Those who are more efficient, they are getting more generation, they are getting more share. Those who are less efficient, their cost of energy is more, they are getting less share. But as a whole, each and every thermal generating station is consuming electricity, and so therefore the coal consumption graph has increased. We have to take care of that. When the coal consumption will be, stabilized, that is, it will not increase. Like, the corona graph, every day I see the newspaper or the internet, I see the number of recoveries are increasing, but the number of affected people is also increasing. That day I will be happy when I see that the number of affected people has been stabilized, and after that it has started falling. Then I will understand that really it is a check on the corona parameters. And same with coal, we must see that it has to come to a saturation. But still the saturation is not here. Here, the prospective figures 2021, 22, 26, 27, peak demand, what can be expected. Today our peak demand is 180 to 190 gigawatt. 2021-22 is expected that it will be 2025.6 gigawatt, and energy requirement billion unit is expected 1566. We are demand reduction due to DSM. What is DSM? I'm telling you. Let me talk about 2026-27. Peak demand is expected to be 298.8, energy requirement 2047, and the energy requirement billion unit where this demand reduction is expected 206 million unit by DSM and 273 million unit by DSM in 2021-22 and 26-27 respectively. What is DSM? Because today we are planning to have more efficiency. We are stressing on what? We are stressing on supply side. That is a generation, transmission and distribution, where we have the power engineers have direct control. But who are consuming? They are consuming the same amount of energy what these companies are releasing, the transmission, distribution and generation companies are releasing, minus their own losses. These are basically as technical losses. Some theft is there. I am not considering the theft. We presume that the theft will be taken care of by the legal department, by the administration. Let us confine ourselves to the technical part. So ultimately, when a consumer receives energy, he becomes responsible for effective usage of the energy. But unfortunately, it is not done in that. Where IT and IoT has a great impact, can do a miracle. But even then, if the consumers are aware, if the consumers know that I can also manage my electricity, control my electricity consumption, and reduce my wastage by demand side management, the total word of DSM is demand side management. That is, the consumer is on the demand side, he should manage his side and try to reduce electricity consumption not by reducing their product, reducing their usage, but by reducing their losses. So if such demand side management can be done by the entire consumer basket in India, it is expected that a huge quantum can be saved. That is, efficiency of the consumers can be improved. By 2021, it is 206 billion units, and 2026 it can be 273 billion. And this is another graph showing the renewable energy contribution in total energy requirement, projected generation from the renewable sources. These two are the figures. I am not stressing these figures. You can well understand. That is, if we can generate 175 gigawatt by 2022, the share of renewable energy will be 20.88%. Unfortunately, scenario 2, instead of 175, we can reduce it. If we cannot reach this 175 target, if we can reach 150 target, it will be basically 18.26%. If we further, restrict it, in fact, this may be a reality because of this COVID situation, then the renewable target will be 15.64%. I told you the wind is a fluctuating one. Now, so the wind target average we have taken. But day-wise target, you see, it is creating a huge fluctuation. This is solar. You can say a 30 days average. Again, these are the averages, but overall you can see it is maintaining a more or less uniform figure. Now, this is an interesting figure. I just want to show you that if 175 megawatt comes, then what will be its impact on Indian load curve? This is basically the Indian load pattern. Right? Now, when the solar will come, this amount of power will be taken care of solar, so the thermal generation has to reduce in the day hour because you have to accommodate the solar power. And in the evening hour, particularly from this, when the solar illuminescence goes down, when the solar impact will be less, the thermal generation has to keep very agile to pick up their load. Problem is that the thermal generation, which is designed for 24/7 operation, that is continuous operation, they are not ready for shifting their services. If we do it, it will be an inefficient one, and for thermal stress, it will have much failure possible. So these are the important points to be kept in mind. So what we will do, what will be our cost, whether we will stop thermal generations or block generations from those who are found to be less efficient. Only we keep some basic generations and manage the evening peaks through battery support or through renewable or through pump storage support. That's a question what the engineers are working very hard. Let us not toil our brain. I'm showing you the problem, and the problem has a solution. How far the solution and how close the solution can be done with the impact of this IoT based solution, that is a point we need to look out in future. Opportunities in generation catering beyond base load, the same thing, load curve. I am just requesting you to keep this load curve in mind. This is basically the load curve of keep this red area. This is basically a area basically fed by the thermal solar generation. Now you forget that there is no solar. So therefore, for India or say for any city or for any area, this is basically a common load curve. It takes the shape like that. It is basically a camel with two humps. The first hump is morning peak and the second hump is evening. And the load curve takes in this fashion. Now, I will come to you when I will talk about distribution. I think I do not have much of time, so I need to be much faster. So let us, I will just keep this thing in mind that basically a two-hump figure, when the distribution comes, how it can impact this. Now, future development was a part in my topic. So, expected future development in generation, what can be that? Supercritical boilers with higher efficiency, having the ability to burn inferior quality of coal. I told you that we need to be more efficient in generation. So, more thermal means more supercritical, more efficient generations, having much less auxiliary power, having much less environmental impact. And right now, you know that all the thermal generating stations having capacity more than 250 megawatt are getting installed with flue gas desulfurization plant. That is why, because we need to improve the environment. Augment hydro and renewable generation, reach on efficient solar power, tidal wave, wind turbine, geothermal energy, micro hydro project. So whatever renewable resources we have, we need to look into that. And how this can be supplemented the thermal generation, mainly the critical time of the thermal generation. That is the rising period. How best the rising period, 2 hours load, that is 5 to 7. This 2 hours load, when the sun is being set and light is, getting lit in the domestic and shop areas, how these loads can be managed. This is one of a very critical problem. Storage and battery. I told you the storage and battery, fuel cells, superconductivity, flexible solar panels. These are important research areas right now. Generation from alternative fuels like husk, sugarcane fiber, bagasse, even from garbage with calorific value. I talked about that. Transmission of electricity was generating in bulk and you need to transfer the electricity in bulk. So transmission of electricity is also very important in today's perspective. Large grids need to be protected from the threat of untoward incident with digital sensitive synchropressor worm system. That is protection from virus, malware, cyber security is a very important subject because today power engineers are prone to threat from other countries or inside the country, outside the country, not by missiles, but by some attack of virus, malwares. They can corrupt the entire data and make hell of the entire network. This is very important. Low impedance power transmission network because we have got problem of ROW, right of way. The every cultivable lands where power transmission lines are set up, towers are set up, people are not willing to allow their land to use this. So how these lines can be made thinner but carry the same amount of load is a very important research area. Develop seamless connectivity to major load centers for ease of open access to bulk transmission. I am not emphasizing on this, is very important, getting open access to bulk transmission. Establishment of transmission network for inter-regional power transmission of at least 16 lakh MVA in next 10 years. Huge setting up of transmission lines and correspondingly sub-transmission and distribution network to reach the newly being set up 16 lakhs MVA. That is the future demand which is being expected to come within next 10 years. And transmission of bulk and renewable power. Now, this is basically you are generating in bulk, you are transferring in bulk. But when it goes to the distribution level where we need the implementation of IoT more, generation we need to have IoT. If time permits, I can talk on that. Transmission requires IoT, but the most required area is distribution and the customer side, the consumer side. Providing 24 into 7 hour reliable power and quality power to all citizens of India, that is the job. First, we should be reliable. My electricity should go to, I am the electricity authority. My electricity will go to my consumer without any interruption. That is reliable power. And second thing is that when you get reliable power, surely we will expect that my power is reliable, but even in the evening, I see the tube lights are flickering. I see at times my fan is getting higher rotation, and at times I can see the count the number of blades. What's happening? The voltages are not regular. So you talk about reliable power, but you are getting reliable power. You are getting power almost a day, but you are not getting quality power. So that is another impact. Bring down the aggregate technical and commercial losses, ATC losses in distribution sector, less than 10%, like all modern countries. In our country, it is more than 20%. Even 25%, 26%, it is written in CA, it is 20.21%. But still, the exact data is not available, but one can be rest assured that it can be brought down to less than 10%. It requires huge change in the MBC system, that is metering, billing and collection system. Usage of proper meters for these crores of consumers, 40 crores of consumers, you can require 40 crore of meters. So you can right now presume that what a big market of meters is needed. And it should be suitably backed by IT, OT and automation. You cannot provide this IT, OT link for the smart meters everywhere because this is very costly. But you need to take care of these, seeing the nature of the business, that whom I will provide more costly meters. If the consumer consumes bulk, and if I don't get his correct bill, I will be losing in my business, then it will come in your mind that to whom are the consumers whom I provide good meters and good connectivity, good networking, so that I can get the correct billing and make the billing correct. Customer focus are the key stakeholders of the distribution business and developing efficient CRM activities. Mind you, tomorrow will not be same as today. You are selling electricity to consumers, they are buying electricity, they are paying for that. So you have to listen to their demand. And today, everything is government. Now tomorrow, if some private players do come, they will become petition. And they will try to prove their efficacy. They will have to be more concerned for the customer. Because the customer has the choice of changing the supply, which is true in European countries. Energy efficiency and solar renewable integration with the distribution network must run in tandem with the normal power purchase of a system. The taboo on DSM and solar installation must be avoided. May not be clear to you. I am not spending time on that because it is little bit difficult for the new people to understand. Now, let me talk to you something on future game changers. Future game changers are the area of electromobility where the liquid or gaseous fuel are being replaced by electricity. E-charging requires a stronger automated high-capacity distribution network, and this is basically, you are replacing the amount of petroleum energy with that of electricity. So presume that good quantum of electrical energy will be required. It will, the possibility of shortage of potable water. Today, India is facing water crisis. So you need to purify water. With demand of filtration, desalination plant will make the demand pool higher. India also being located in the subtropical region and the global warming will make steep demand for air conditioning equipment. You all understand that every summer the demand of air conditioning goes up, and every time those who work in, those who are in their respective electrical authority, they apply for some additional loads whether shall be installed air conditioner or not. And the use of stronger communication, automation, and IoT applications are still strong growth engines for power demand and needs strengthening of distribution. Now, the role of digitalization in reshaping the electrical sector. This is basically, the transportation sector. There will be digitalization. The homes, digitalization, smart home. Industry, I told you, it's a very good area for using more IoT-based equipment for their energy management. Business houses, everywhere. And power generation, transmission and distribution, all will be seamlessly connected to the system. Objective of a modern power company: extraction and treatment, primary energy supply, import and export, stock exchange. Now, in the primary energy company, in the energy power company, these are basically one basket where it is supply side. Supply side means you are extracting, you are getting the resource, either you are buying electricity from a different company or you are producing your own electrical generation unit. You are a primary energy supply, you are export from a stock exchange. Basically, this is a collection area where you are getting your electricity, maybe your own generation, maybe you are buying from somebody else. This converts transformation. Now, whenever you are, it is a process system. Whenever you are buying electricity or you are procuring electricity from your own resources, you need to convert. That means you cannot sell that raw electricity. You are buying it or you are producing at 10 kV, you cannot sell it at 10 kV. You are buying it at 400 kV, you cannot transfer it at 400 kV. So you need to transfer it through different systems so that it can reach to your consumer. Your consumer may be a low voltage consumer, your consumer may be a high voltage consumer. So depending on the consumer's requirement, you need to transfer it through what? Transmission and distribution system. In the well, some amount of energy loss will take place. You need to account for these losses. And through this, it is going to the final energy, going to the end-use appliances. There are also energy losses, and ultimately the useful energy going to the consumer. But again, this useful energy is useful to you, to an utility, because he is billing for that, but it is not that useful to the consumer unless he takes care of his own usage immaculately without any unwanted losses. Losses will be there, technical losses you cannot avoid. But if you run the machine being unattended, it is free motor rotating, then you understand, say 500 kilowatt motor, if it is not loaded, it goes on freely rotating or pulling a conveyor belt with a static load. You imagine what amount of losses the motor is taking. You could have made a sensor so that when there will be no load on the motor or the conveyor system, the motor will stop. Could you not save some amount of electricity? These are the usage which is done by the IoT system. So the usage of IoT is becoming very, very important. And for distributed generation, let me tell a few words that distributed generation, suppose what happens that you are planning an electricity system for a small city and you are having some distributed generation. Say you have got 2 wind turbines, you have got 3 say some amount of batteries, some amount of solar. Now, in the evening hour, when or in the city, there are few industries also, small industries. Now, when the industries are taking load and your input quantum is becoming more, you can see, you can measure your input transmission line is on the process of crossing its limit. Suppose the limit is 50 megawatt. The input quantum has become almost close to 50 megawatt. Now, what you can expect? You can expect that you can draw further amount, but you have to pay a hefty bill for that. Is it clear to you, I think? that your limit is 50 megawatt for which you have set your system. Now, if you can draw more than 50 because some industry is taking more load. Now, if you draw more than 50, system will not stop you, but system will charge you a much higher quantum if you draw more than your allocated. Then what else you can do? You have got two things. You have got switch off some amount of load so that it can be contained within 50. You can do, or you can restrict the industry who is taking more not to take. But the industry has got definite necessity, so if it takes, it will be good for the industry. So you are not also intending to stop them. Now, what are in your hands? Either you switch off, or you restrict the industry, or you allow more load to come in, or the fourth one is that you allow some additional generation to be pressed into your system so that it can come. Now, if the industry has got a set of, say, diesel generator. Diesel generator is not a good one, but I am considering this just for the discussion. Now, if the industry sees that the system wants the diesel generator to be on, then the diesel generator will be placed into the service and the city demand will be restricted in the 50 megawatt zone. You forget about the city, you consider this is an industrial setup and the entire bill is coming through one unit and many other industries are sharing the electrical network. Now, this can happen to any of the industries. So, whenever load is coming, either you get some sensor, maybe it's a current sensor, it can check that it will be drawing more than the allocated demand, or if sudden load comes up, if the voltage dips, you can see that you are within the current limit, but for some reason, for some huge reactive pool in the system, the voltage has gone down. Now the voltage has gone down, you are supposed to operate at 11 kV input voltage, now voltage has become, say, 10.3. Many of your industries are feeling, much more current demand because the voltage has gone down, and some machines which are operated at very voltage sensitive, they are also stopped operating. Now, what you are expecting, you expect that some of the capacitor banks in your system to be switched on. So the IoT system allows the capacitor banks to be switched on, or you have got a different system of giving more generation to it. You have got a distributed generation system. Some wind turbine, it senses that the wind velocity is good and the wind turbine gets pressed into the sun. It is serving you both the reactive load because it is fed by a asynchronous generator. It can give you some inductive loads. At the same time, it is giving you some amount of power supply. So what is happening in a small system? If there is sensor operated IoT devices and checked with distributed generation, maybe it's a diesel generator, maybe it's a battery setup, maybe it's a wind generator, maybe it's a solar. It can happen in the daytime and solar system may be placed into service. So this thing can happen. So in a distributed generation system, if IoT systems are there, IoT operating systems are there, they can be operated very systematically and synchronously to get our system more sensitive, to operate the system in a more effective. The components of an IoT system. IoT employs sensors and communication technologies for sensing and transmitting real-time data, which enables fast computation and optimal decision making, and IoT transforms the sector to a distributed, smart and integrated energy system with distributed renewable resources such as wind and solar energy. Distributed generators are often termed as prosumers by aggregating their generation and optimizing their demand whenever useful for the grid. The application of IoT in the energy sector, starting from energy generation to transmission and distribution at the demand side, are the key areas for concern of all. Now, what is Internet of Things? Internet of Things, as I understand, it is giving in 5 different blocks. One is I01 IoT applications. The block 1, the circle 1 is IoT applications. IoT is an emerging technology that uses the internet and aims to provide connectivity between physical devices or things. Physical devices, which are basically the on which I operate, and the physical device and the internet. It creates a connectivity. Examples of physical devices include home appliances and industrial equipment using appropriate. Suppose this physical device may be in industrial equipment, maybe a capacitor bank or maybe a solar plant. This solar plant, when gets switched on by some sensor operation of, say, lower illumination, which is happening inside an industry, the light sensor operated IoT operates and gives information to the solar plant. The solar plant gets switched on and gives additional electrical power for the additional set of electricity and electrical bulbs in the plant. So it's a simple operation of IoT-based things. Using appropriate sensors and communication networks, this device can provide valuable data and enable offering diverse services for people. IoT has a wide range of applications. Now in Circle 1, the first step in designing IoT system. This is basically IoT application. The selection of components of IoT such as sensor device, communication protocol, data storage and computation needs to be appropriate for the intended application. The figure shows different components of an IoT platform, IoT devices. The second component, IoT devices, could be in the form of sensors, actuators, IoT gateways, or any device that joins the cycle of data collection, transmission, and processing. And IoT gateway devices enable routing the data into IoT system and establishing bidirectional communications between the device and gateway to cloud. The communication protocols, the third component of the IoT platform, enable the different devices to communicate and share their data. Basically, unless the IoT communicates, it is not possible to transfer the data. And making a decision-making center, IoT platforms offers the flexibility of select the type of communication technology. So when there is a communication, it has to depend on some communication technology. It can be 5G, it can be Bluetooth, it can be Wi-Fi, it can be Zigbee, it can be some other. And cellular technologies such as LTE, 4G and 5G network, the data storage or the fourth component of the IoT platform that enables management of collected data from the sensors. In fact, this data storage is this 04 data storage is a very important area. And from the data storage, there is another part. The data collected from the devices is very large because it continuously goes on sending data. So segregation of this data and identifying the importance of the data and putting them into service is another area of very, very important areas, which is done by the data analytics platform. So I am having flooded with data, but what I will do with this data? These are done by data analytics. Now this is basically a traditional power grid and this is a smart grid. So this smart grid, is having all the generations, distributions, everything, but which are very intelligently coupled and can, talk with the own computer and take decisions on the system. Now this smart grid, smart meter, and talking about a smart meters example, and you will understand that how the smart grids are operating. Smart meter is something, meter, it is an instrument which is kept in a consumer to monitor the energy. Earlier and today, these are the prime concept of metering. Now the smart meters are little more than that. What it does, why it is smart? Because the smart meter can communicate. So whatever data the smart meters note, the smart meter requires that some action may be required on this particular data. Suppose I'm giving you an example that how you tune a smart meter or how you advise or program a smart meter, it operates on that. You are having a smart meter in your home and you are connected through IoT devices, through your watch or through your laptop or through your smart mobile set. Through an app it is connected and the app is sensed by the IoT, which is kept in the smart meter. And you have got IP addresses both so that you can communicate to each other. Now what happens, you have instructed the smart meter that when I leave, say at 10 p.m., from 10 a.m., except my kitchen where your fridge are kept, all individual switches will be switched off. The smart meter accordingly carries the instruction. It has got some multiplying switches. It switches off all the instruments. And again, you have instructed the meter that at 6 p.m., usually when I return, all this will be switched on. Moreover, the AC to be switched on. When I enter, I must fill a code, ambience. So it does accordingly. So it follows your instruction. Again, the smart meter, you have instructed that if somehow the current goes up beyond this limit, you please give me an alarm. So you have set an alarm. If it goes beyond the entire, when you are in your home, you have switched off all the ACs, all the gadgets and everything, and you don't know the current has started increasing. So when you see a beep, you see that, okay, something has happened. Let me see. You see that the current has increased beyond the limit. So you check and switch off what is not desirable. So these are the things. Suppose a fault has taken place in your system and the smart meter gives you a beep that some huge quantum of current has gone because of this, and the smart meter is well trained, it has stripped its system because it has gone beyond the limit. So a smart meter can do these things and it can communicate you through a communication device. It can be any of the communication devices. Now, what are the communication devices? Wireless communication systems play a major role in. Now, the feature of smart grid, let me talk about the feature of smart grid. This is important, self-healing. I talked about consumer. The consumers want fast, some good behavior from the distribution company. Now, one of the good behavior is that if there is any failure, how fast you can restore it, how far, suppose in Amphan, if you could have got your supply within 2 hours, definitely would be very happy to the supplier because the supplier has given back your supply. You would have been more happy that if your supply won't have gone. But at least since an Amphan situation, you could definitely forgive the utility because such a difficult time. So if my supply goes for 2 hours, I won't mind. But if it goes beyond, say, 2 days, surely you will mind. Now, this is basically reliability and it has got a cost behind it. Now, self-healing is also an example of very high grade of reliability. What is that? If there is any fault in the network, the fault should get isolated automatically and your supply should be restored from a different region. So you would understand that there is a failure in the system, which we call self-healing in our system. Now, had the fault been healed by your system? No. It has got given you a different path so that you can assume that the fault has got rectified. For this, you need to have a standby source of supplies, number one. Number two, standby and automated of self-operating and very sensitive protection system, which can identify the location, zone, and isolate the faulty section and give your supply, sensing that your voltage is off. So it will sense that you have not yet got back your supply and put different resources and finally switch on. Everything will be done. It should be resilient against both physical and cyber attacks. So number one, it should be reliable, self-healing. It should be resilient. Third one, active participation by consumers in demand response. That means it is responsive. Demand response means when your demand becomes more, if the utility fills, if the demand becomes more, what happens? Two things. One, the voltage will fall. Second, the frequency will fall. So either voltage sensitivity or frequency sensitivity, you can assess the situation and take corrective action, which is again automatically. So some amount of load will be shed, some amount of voltage will be reduced, either blackdown effect, that is load shedding, or browning effect by voltage reducing. You can make your system back to normal. So this is sensitive. Accommodates all generation and storage options, that is uniform. It will accommodate all generation and storage actions, but it will put into service when the economy permits. Enables new electricity market, which is again of uniformity indications or economic actions. Optimize asset utilizations, so your assets should be properly utilized. The smart grid will take care of the asset management. Provides quality power. Today, consumers are not only happy in getting power, they are thinking about the quality, and it should optimize operating efficiency. The smart grid or the smart system is eyeing for that. It is ultimate objective is to operate with the highest degree of efficiency. Now, this is a conceptual model. Bulk generation, transmission, distribution, customers, operation, markets, and service providers all are under this bulk net of this smart grid, and everything is controlled by IoT. There is a communication network, home area network, HAN, neighboring area network, NAN, field area network, FAN, or wide area network, NAN. Due to paucity of time, I am not stressing on these networks, but I am giving you a very brief idea that there are so many technologies. That is LoRa technology, which is low range output, which is basically, power usage is very low, and range is almost 50 kilometer. Example, this is used in smart buildings or in smart grid activities also, because within a 50-kilometer range, if you've got an industrial setup, within the industrial setup, you can make this LoRa applications. NB-IoT, it is also a narrowband IoT. It is within a range of 50 kilometers. kbps is more, so you can transfer more data. Power usage is comparatively higher, and it is used for smart grid communication. There are others, LTE-M, which is used for 200 kilometers. This is used for smart meters. In fact, Calcutta smart meters, if it is installed, LTE-M can be used. Sigfox is another technology. Weightless, another technology. Bluetooth, all you are concerned, aware of Bluetooth. Zigbee, it is very common, and satellite, very costly, but it is also used for solar and wind power plant or remotely distantly located power plant. So these are the communications. Zigbee is given. I'm giving you a little bit more on Zigbee because it's very common. Zigbee is the most popular low-cost, low-power wireless mesh networking standard in the market right now. So in Zigbee, although the range is 100 meters, but with mesh networking, its range can be increased. It is typically implemented for personal home area network. Benefit of ZigBee is that nodes can stay in sleep mode most of the time, so battery consumption is less. It cannot easily communicate with other protocols. Additional mechanism is required to communicate. As I do not have much knowledge on communication, I cannot talk on this topic in details, but I understand that protocol is a very important issue for communication. So, and every network or every IoT equipment cannot communicate with other one. So there is a uh, network protocol and interoperability issues are there. So that has to be taken care of. Since this is a developing subject, people working on this must know much better in this particular field. IoT role in smart grid, application layer, presentation layer, and perception layer. In three layers, IoT operates. Application layer means smart homes, smart cities, electric vehicle, renewable energy sources, power lines. Presentation layers, which operates with the networking, gateway, ZigBee, Bluetooth, Wi-Fi, and others. And perception layer, these are wireless sensors, RFIC, and cameras. They directly operate with the presentation layer. Now I talked about data analytics. So data center is important, where the distribution networks, power plants, smart factories, smart buildings, farms, all these data are, kept in the data center. And next thing is that the data center data, if it is, gets continuously reached with this influx of data, it will get overloaded. So in many cases, the data are kept free with that of cloud computing. So this cloud computing is also very important. Computing and analyzing the data generated by IoT allows accurate response to the system and helps making suitable decisions on energy consumption of the system. However, computing IoT data is a challenging issue because IoT data, known as big data, refers to huge amount of structured and unstructured data. As I told, that every data, if keep parked in data center, that will unnecessarily overload the usage of data. So duty and characteristics of big data, which are big volume, high velocity, and high variety, it needs to be efficiently processed and analyzed. Advanced computing and analytic methods are needed to manage this big data. And the following explain cloud computing and fog computing, so which are presently used. Cloud computing is a data processing approach that offers services, application storage, and computing through internet and allows computation of data streamed from IoT devices. Although, and fog computing is that cloud computing is one of the best computing paradigm for data processing for IoT applications. Due to delay and bandwidth limitation, centralized resources that are used for data processing, more efficient ways are required. Fog computing is a distributed paradigm and can extension of the cloud, which moves the computing and analytic services near to the edge of the network. So both type of computing methods are used. Data analytics, many people, many engineers, technocrats are working with data analytics, and it is relating to new results, new type of decision making are coming through this. And artificial intelligence is based on this big data analytics. So this is a new and developing subject. It is getting integrated with power systems. And the role of IoT in home management and in smart grid. I have already given an example on that. IoT in smart energy applications, I also have spoken on that. So another point I just need to stress upon is that it is almost end of my presentation. That power quality, as I told you, is becoming a priority area. What you are giving when a customer is buying, presume that he buys it with happiness or not. That is the ultimate criterion. If he is compelled to buy, and if he does not have any option, you must not be very happy because he is basically compelled to buy your product, your electricity. Had he been a choice, should surely have tried to get a different taste, different, different vendor you would have tried. But today in electricity, the opportunity is not there, but tomorrow the opportunity may come. So we must be very cautious about maintaining the quality. Quality maintaining does not only indicate on voltage, but indicate on frequency also, because we are supplying frequency, say 50 cycles, and voltage and 230 volt. Now 230 volt means it should be close to 230, and 50 means close to 50. But the utility is supplying 50, but due to various reasons, harmonics and other reasons, due to continuously usage of nonlinear loads, the harmonics are getting only present in the system. So you need to get rid of that, which also requires IoT services for making your system free from impure power quality. So the system is gradually increasing. It is gradually, overspreading with more usage of IoT and smart applications. I tried to, tell you something. I have in fact surely exceeded my time. So please excuse me for that and let me know what you have, whether you have enjoyed the session or not. Thank you.
Sir, it is an excellent and informative and mind-blowing presentation. Now, I am requesting the participants, if you have any question, then you can write in the YouTube chat box. Sir, I have a question.
Yeah,
Hello?
tell me.
Yeah, sir, is it possible to switch to a fully sustainable global energy landscape within next 20 to 30 years?
Global energy landscape, it's very difficult to say. In fact, you see that many of the countries, particularly in the European countries, they are trying to make their energy system, more to prone. I mean, green energy, more to green energy. Say Germany, say Norway, but India being a very vast country, and we don't have much of economic strength, so it is not very easy to convert our system to a green one or zero carbon with zero carbon footprint. But we must go on trying, and the less we can release CO2, the less we can pollute our system, the best we can do for ourselves. Right.
Okay. Questions? So, on behalf of the Electrical Engineering Department, sir, I am sharing the certificate of appreciation.
Thank you.
Sir, is it visible to you?
Not yet.
Thank you, sir. I joined late. I actually our meeting will start. It's Navamita here once again. So thank you, sir, for joining with us here.
Yeah, I got your certificate. Thank you so much. I know that I have, exceeded my time, so I'm extremely sorry for that, because when I talk, I just forget of, checking my watch and what had it in my mind I wanted to express. So thank you very much for giving me the opportunity. Thank all the
Sir, it
participants.
was an excellent presentation, and thank you for sharing your valuable time with us and also the knowledge. We hope to have the opportunity to get your such enlightened lecture again in the future. And I want to extend heartfelt thank you for your contribution to making this session so successful. Thank you, sir. And our next session is starting. So I am requesting Ms. Kamalika Banerjee to next lecture session.
Thank you, Priyanjali madam. Uh, a very good afternoon to all the participants and respected delegates present over here. So I feel honored to introduce the next speaker for the session, Professor Dr. Paromita Chattopadhyay. So it's my privilege to read her achievements. Professor Paromita Chattopadhyay received the BE, ME and PhD in electrical engineering from Bengal Engineering College and Science University, Shivpur, India in 1993, 1996 and 2002 respectively. Currently, she is an associate professor in the Department of Electrical Engineering, Indian Institute of Engineering, Science and Technology, Shivpur, formerly Besu, Shivpur, India. She received Young Scientist Award, DST, Government of India, and Commonwealth Fellowship UK in the year 2002 and 2003, respectively. She was the visiting professor in Hanyang University, South Korea in the year 2008. She has executed number of sponsored research projects funded by DST, AICTE, CSIR, IE and NPP projects of CPRI, Ministry of Power, Government of India and developed laboratory with the state of the art facilities in the area of condition monitoring of rotating machines. She has published more than 50 research papers in various international journals and prestigious conferences and filed 2 Indian patents. She has already guided 3 PhD and 25 MTech theses. 4 more PhD scholars are working under her supervision. Dr. Chattopadhyay is an IEEE member. She has already taught the courses like electrical and electronic measurement, signal and system, soft computing, AI and ANN in undergraduate level, and conditioning monitoring of electrical equipment, application of soft computing in electrical engineering in postgraduate level. She is a passionate researcher and her research interests include condition monitoring of electrical equipment, machine learning, signal processing, design and development of intelligent systems, AI based smart grid management, energy informatics, learning in control, and applications of nanotechnology in power and energy sectors. So, with this introduction, I would like to invite renowned Professor Dr. Chattopadhyay, to start the second session of this STTP program. Thank you, madam.
Thank you. Thank you very much for your introduction. So let me start the session. Very good afternoon to all of you. So let me share my screen first. Okay. So is it visible? Hello? Hello?
Yes, madam. It is visible, madam.
It's okay. Thank you. So, let me start. My topic is energy informatics. In the last session, already the speaker has already done a lot work for me. So I think I don't need to spend much time on the introduction part. But still, I would show you some couple of slide just to prepare the background of my lecture. So this is the layout of my talk. I would start with introduction, where the new things which I would like to mention is the big data issues, sensors in smart grid ecosystems, Then I would come to the topic energy informatics, its definition, objective, and scope. Next, it would be the deployment of smart sensors and energy efficiency. Then the last but not the least is wide area measurement system based intelligent monitoring and control, where I would try to emphasize the renewable energy integration and its negative effect on grid stability, and where is the need for wide area measurement to mitigate that negative impact. Next, the phasor measurement unit, which is the heart of the wide measurement systems, then followed by the PMU-based data analysis tools and techniques, and deep learning-based grid event classifications. Lastly, I would like to mention the challenges and open issues and future scope in this area and the references. So we all know, you know, because you are at the end of the this program. So you all know that the energy plays a very instrumental role in any development, socio-economic development of the country. It has a very good correlations with the GDP and the economic development of the country. So if we look into the energy map of India and some of the developed countries, we would see that the per capita energy consumption of India is much less than the per capita energy consumption of the developed country. This is the per capita energy consumption of India, and this is the per capita energy consumption of the Europe. So in future, India need energy, but normally, even if in our 10 years back, energy means we understood the traditional fossil fuels. But you all are aware of that in the year 2015, our common future under climatic change in the Paris in July 2015, we all the consensus among the climate scientists, it was clear that this man-made greenhouse gases are leading to dangerous climate changes. So as a result, what we are getting global warming and some adverse effect on environment. So in that so 2015 is the pivotal year for in energy roadmap, where the scientists took an oath that we must have to effectively manage our load. We have to reduce the losses, and we must have to integrate large amount of renewable energy generation to get a sustainable development. That means basically we have to reduce the carbon footprint. That is the main major motto. So the Paris New Climatic Change Agreement, the three important steps were taken that you already know, that is the reduce carbon footprints, increase renewable energy, and the energy efficiency. So these 3 points are introduced. So to reach this reduction of carbon footprints, increase renewable energy and the energy efficiency, what as a power engineer, what can we do? So if we look into the global carbon dioxide emission by various sectors, we would found that the industry, they are the major contributor, followed by the buildings and the transportation. So we would focus on this area, how we can reduce, make this areas energy efficient. So, these are some figures, some statistics, or I'm showing where the greenhouse gas mitigation versus cost-effective energy efficiency are represented. From here, you can show that the orange color, it is indicating that it is very easy for the building to make it energy efficient. Low cost emission reduction, because we can, if you just invest a very small amount, we can make it energy efficient. And another area is the transport also. It is possible to make it energy efficient. And another area is the energy supply. So our building, transport, and the energy supply, these are the low cost emission reduction is possible. So these sevens are the areas where we can reduce the greenhouse gases, but these very transportation and the building are the three important areas where we can reduce the greenhouse gases in a very cost effective way. So here I am representing some low carbon hierarchy. That when we are talking about we have to reduce the carbon footprint. So how can we do it? The first thing is that we can reduce our demand. Second is we can make our system energy efficient. Third option is the renewable energy or integration of renewable energy, because as here I'm showing the cost, because as we are moving upwards, that means its cost is increasing. So first cost effective thing is to reduce demand. Reduce demand means not only reduce demand, but without hampering our comfort level. And then we have to design for the energy efficiency. And third one is the renewable energy integration, because the renewable energy integration is not very cost effective. So in rest of the part of my lecture, I would try to emphasize how we can make reduction of our demand without reducing our comfort level. How can we make our system energy efficient? And finally, definitely we would come, because these two sectors we can contribute, but we must have to integrate the renewable energy to meet up our ever increasing generation. So these are the typical share of renewable energy in India. Already, I think you have seen several speakers have talked with you. The major thing which I would like to emphasize, that the coming years, what is happening from here, you can see that the integration share of various renewable energy is day by day increasing. So the new power capacity which is installed addition in India, they are mostly of renewable energy in nature, which is indicating by this. So the major share showing 2018-17, 4% of the new energy capacity was in the area of renewable energy, and where major share is the wind, then the solar and the biopower and the small hydro. So as my earlier speaker, they have also mentioned that we are moving towards a smarter grid. That now question is, where is the need for the smarter grid? Because as we have mentioned earlier, that we need to improve our environment. We must have to enhance the value for the energy, improvement of energy efficiency, and we have to improve the quality of our life. So there are both economic and environmental urges for transmission from the current updated power grid to a sensor-embedded smart grid that monitors system stability, integrated distributed energy, and scheduled energy consumption for household users. So mainly we are moving towards the smarter grid from two important concern is there. One is environmental issues, another is economical issues. Generation, power electronics converters, harmonic and power quality issues, smart sensors and intelligent grid control, electric vehicle and electric storage. I think here nothing new to explain. All you are aware of that. So I would go to detail of my topic, energy informatics. So in smart grid, there are various smart sensors, or what are those sensors? That is one important sensors in the smart grid. It is discussed a lot, I think, that are the smart meter. Another important sensor is the PMU, phasor measurement unit. Another is intelligent electronic devices. Other sensors are smart solar inverter, weather data, video surveillance camera, and we are getting so many sensors from the electric vehicles, wind power also. So these are some typical examples of smart meter sensor data. So in my next phase of my talk, I would discuss what is the function of these sensors and how the sensor plays an important role to take the important decision in the smart grid, to make our power system much more efficient and help to integrate renewable energies. So the sensor data which you are observing from this smart sensor data, basically we can divide the sensor data into 4 categories. One is smart meter, and that is grid equipment. That means phasor measurement unit and all these things, which I would come in detail. Another is off-grid data. Off-grid data means the weather forecasting data is required. Another is asset management data. That for monitoring the entire power system, we need this data. So these meters are connected with the various part of the smart grid. And these meters are generating a massive amount of data, which is known as the big data. And 4 V's, that is the velocity, volume, varsity, and variety, is the 4 key words in big data, in smart grid-based big data. Why the velocity? You try to imagine in smart meter, every 5 to 15 minutes, we get some data. Phasor measurement units, we get 240 samples per second. The intelligent condition monitoring, we get 250 samples per second. Digital fault recorder, we get 1600 samples per second. So we get a terabyte order of data in a month. So that's why it is known as the big data. Big data means, big data is, in today's, big data is gaining much importance because sometimes it is called the So the definition of the energy informatics is that it is a concern with analyzing, designing, and implementing systems to increase the efficiency of the energy demand and the supply system. This requires collection and the analysis of the energy data set to support optimization of energy distribution and consumption network. So this is the formal definition. Another definitions I have also written. The energy informatics is concerned with the information and information flows in the energy system, especially use of computational methods to increase the efficiency of the energy demand and supply system. So basically, the energy informatics works with the big data received from the energy system from the various sources. It analyzes it and try to extract some information which helps the energy system for optimized to make it energy efficient. So what are the objective and scope of this energy informatics? The energy informatics exploit the state-of-the-art information and communication technology to tackle the global warming and climatic change challenges. The scope of energy informatics includes computing and communication technologies and their application for sustainable energy sector, that is smart grid, solar, electric vehicle, and storage. So it is expected, as we are using information and communication technology in the energy sector, here the main objective of the energy informatics is to increase the energy efficiency beyond the traditional engineering, number one. Number two, the efficient integration of renewable sources of energy by making power systems smarter. Because when we are all talking about the integration of renewable in the power grid, we must have to think there are several advantages like reduction of carbon footprint, but at the same time, renewable energy is throwing several challenges and negative impact to the grid, particularly the grid stability, which I would discuss in my later changes. So the energy informatics not only works for the energy efficiency, but it also works with the efficient integration of renewable energy sources by making our power system smarter. You have to keep in mind one thing when we are talking about the renewable energy. You have to keep in mind that we cannot integrate any amount of renewable energy to our grid. It depends upon the many things. Now, can the energy informatics help us to determine how much amount of renewable energy we can integrate in the system? It is a very important goal. So energy informatics can play an important role for control and monitoring the renewable energy integration to our grid. In this lecture, I will try to emphasize this topic, that how we can intelligently monitor and control the renewable energy. So before going into the detail, I just show you some couple of slides for the smart grid ecosystems to make our power systems more cleaner, greener, and smarter. So the smart grid ecosystem, as you all know, it started with smart home, smart building, smart city, and smart entire system is the smart grid. It is embedded with various so-called, you were talking about the Internet of Things. I would call it some smart sensors with the communication, both way communication facilities there, and we are taking lots of data, we are getting lots of data from the system, and this data and these data are very important to us. How we can utilize this data with the help of various computational intelligence technique to extract knowledge, and we can make our system more efficient and more reliable. So first is, you all know, in the smart home, as it has already mentioned by earlier speaker, I think, the lots of intelligent sensors are embedded, which is part of the smart home system. It may be the temperature, humidity sensor. It may be in the classroom. We can install the carbon dioxide sensor, and based on this thing, we can sense all this thing data. But now the question is that we have placed several several sensors, or you can call it the IoTs, Internet of Things. And from that smart sensors, we are getting huge information. Say for a classroom, we have inserted 2-3 sensors, like we have temperature sensors, humidity sensors, and the carbon dioxide sensor. The main objective is that we want to control our lights and also the illuminating sensors. Main objective, we want to control the air conditioner. Now we are getting data from the carbon dioxide sensor. We are getting data from the temperature and the humidity sensor. Suppose from these 3 sensors we are getting data. Now, how we would design the controller for the air conditioner? We are getting data, but how would we design the controller? So this designing of this controller, that means developing the algorithm, that is a software issues, and to implement this algorithm into the hardware platform is really challenging. So we can say easily that we would use this 3 data from this sensor, and we would design the controller, but the designing the controller involves various issues, because we don't have know the exact correlations. We know that when the temperature of the outside is more, we should increase the AC on, or in the higher level setting should be more air should be flow inside this. And depending upon the humidity and the carbon dioxide level, when go on increasing, then the more fresh air should be within the room. But these thing we are saying. But when I would ask this qualitative decision, you convert it into the actual designing of controller. It's difficult in this sense because this linguistic linguistic decision we have to implement in terms of the numerical one. So these are the major challenges in designing this controller and their implementation in the embedded platform. So this is energy efficient home from energy efficient building, for which we need the energy efficient equipment and system, and the human behavior too. This is very important. Even if we have the equipment and system energy efficient, our behavior must be energy towards the energy efficient. So the combination of the equipment system, we can get the energy efficient building. So Next, I am talking about one of the most important, because we all talk about the smart meter. I would like to more specifically tell few time for smart meter data analysis, particularly smart energy meter data analysis. So, conventionally, you are aware with energy meter. All of you, as an electrical engineering domain, you are aware with the energy meter. Initially, it was an induction desk type energy meter. Now it is digital meter. But we are moving towards the smart meter, smart energy meter. In what way smart meter is different from the conventional conventional energy meter is that definitely the both way communication. Normally we have seen that every month a person come to our premises or house to take the reading of the meter, and the next month it would come and automatically it would then the 2 meter readings, the difference it would get, and according to we would able to know what is the total consumption of power in the last month. But in the smart meter, the concept is totally different. Here, in every 15 minutes, the consumer would able to know what is its power consumption. And it is in future, it would be as the energy market would be priced, is an open price, flexible pricing in the energy market. And it would be able to know that what is the pricing of the energy at that moment. Depending upon this information, the consumer has the choice to select whether whether he or she would use more power at this moment, or he or she the consumer may shift his work in a different time when the price of the energy would be lower. So in this way, the consumer may be benefited. On the other hand, the supplier may be benefited. Utility may be benefited because it is getting the supplier is also getting the information, getting the pattern of the consumer behavior, energy consumption pattern, and which may help in future to predict the load of the system. Why it is important to predict the load forecasting in future? Because if the utility knows the consumption pattern of a consumer in future, it would help him to it help the utility to predict the load consumption, load forecasting, and helps to better management of the system. So in this way, the smart meters are very, very important, smart energy meter for management of the smart grid system. So now thing is that another important thing is that we all know that in the buildings we have the solar panels. The solar panels, they are so during daytime, the solar energy is generated. Sometimes this energy is used to meet up the demand of the house, and if the energy consumption is exceed, that can be fed to the grid. That means if can be fed to the grid, that means the energy is flowing from the building to grid. And sometimes when extra energy is needed, so it would grid to building. Energy would flow from the building to grid. And now nowadays, whether a consumer would send the power to the grid, or it would store. That depends upon depends upon what is the price of the electricity at that time. At that time, if the price of the electricity is less, customer may not sell the electricity, feed the electricity to the grid. It may store, and when the price would increase, it might sell. So it's just like the share market. Energy market is not just like the share market. When the prices go up, we would sell the energy. When go down, we would not sell, we would store the energy. But for this thing, we are talking about this, but how to control this one? So here we need a controller and a decision making and the sensors and the sensor data and some informations. This information data should be analyzed, and according to this, we do some control actions. All things I think it has been discussed earlier. So the low carbon transportation, which is the smart vehicles or the electric vehicles, which is very much in. Here also, the smart vehicle also, here we have the similar concept of grid to vehicle and the vehicle to grid, because a smart vehicle, it also carries some batteries, lithium-ion batteries, and it can be used as a storage unit. And when the grid needs more power, this battery stored power in this battery can be utilized to meet up the grid. In this way, in the smart way, it can manage this thing. So the idea behind the vehicle to grid is similar to the regular smart charging. The smart charging enables to control the charging of the electric cars in a way that allows the charging power to be increased and decreased when needed. And the vehicle to grid goes one step further and enables the charge power to also be momentarily pushed back to the grid from the car batteries to balance the variation in energy production and consumption. So when the grid needs power, the power would be pushed back from the battery to the grid. And on the other hand, when the charge battery would needs to be stored, it would be grid to the vehicle. But as we are talking about, there are so many issues like power qualities and all these things. But as we are discussing on the energy informatics, I would like to emphasize on the data-driven control, because all these things, grid to vehicle or vehicle to grid or building to grid or grid to building, all these control actions would be done on the basis of some decision, and this decision would be taken from the sensor data which we would get, and some algorithm or decision making algorithm would be used to take the decision whether it would be grid to vehicle or vehicle to grid or building to grid or grid to building. Now, what are the algorithms that we can use, and how to implement this algorithm in actual embedded platform? Is it easy to implement those algorithms to implement in the embedded platform? These are the great questions, and I think one of the topic of this program. So one by one, we would enter into more detail of this algorithm part. Here I would just try to prepare the background. What are the data and how and what so from where we are getting the data. So the mainly this is so far I have all discussed are the sensor data, or you can say the IoT, which are mainly used for make our system energy efficient or to intelligently control our demand. Because in the smart grid, one important concept is the demand side management. So these are to make our system energy efficient and the demand side management. But now the question, now a next phase, I would come to it. Apart from that, to meet up the ever-ending increasing of demand, only the energy efficiency or the demand side management would not sufficient. We must have to penetrate a large scale of renewable energy in the grid in terms of the wind energy as well as the solar energy. So when we would penetrate a huge amount of renewable energy, what would be the scenario? So this is the typical schematic representation of the future energy market, where we have the energy consumption, building level, and transmission distribution system, energy production. And you see that schematically what we are showing is that now at present our energy price is fixed, but in future, depending upon the supply and demand, price of the energy would vary. Depending upon how much is the supply and demand, whether because the renewable energy, one of the important features of the renewable energy is their production is variable in nature. They greatly depends upon the weather forecasting. So that's why depending upon the weather, the availability of the renewable energy may vary, and how our smart grid can intelligently control this variation of renewable production to make the system handle efficiently. So in that way, the energy informatics can play a great role. So next I am coming to a very important topic, which is, I think, the heart of my today's talk, that is wide area monitoring, system-based intelligent monitoring and control. As I mentioned earlier, and I think earlier various speakers have also mentioned, that the renewable energy integration in the grid causes a voltage and frequency stability issues. More the renewable energy means less grid stability. The question is why? If I just look into the fundamental of the power system operation, we see that we have some generation and we have some demand. So when there is a mismatch between the generation and power, the frequency, there is a disturbance in the frequency balance, and it is this variation of frequency that depends upon what is the inertia of the system. That means if I mathematically represent, this is delta P, which is a mismatch between the generation and power. Fundamental equations in the power system, it is equal to the inertia of the system into d omega by dt. Omega means rotating speed of the system. That means omega means twice pi into f. And where each system, inertia of the system is summation of the various system. What is the inertia of the system? The inertia of the system means it is the inertia of the variable renewable sources, various generating sources. It may be the traditional fossil fuel, it may be the renewable sources. So in today's grid, we have both combinations of the traditional as well as the renewable. So H means basically the inertia J into the capacity. So H is becoming the inertia into the capacity. So the inertia of the fossil, traditional thermal power plants and other fossil fuels, they are very high. But on the other hand, the inertia of the renewable energy is very low. So when we are penetrating a large amount of renewable energy, the effective inertia of the system, that is H system, is reducing. So if I represent d omega by dt, which is nothing but the delta P, mismatch of power divided by 2 into H into system. So as it is clear, it's very clear from this equation, if the inertia of the system is reduced, d omega by dt would increase. That means rate of change of frequency would increase. So as we go on penetrating large scale of renewable energy, it would cause a huge amount of dF by dt. Lower the system inertia, higher would be the rate of change of frequency. So what would happen if the rate of change of frequency is high in a system? If the rate of change of frequency is very high in the system, what would happen? In power system, for the protection purpose, we use various protective device like frequency protection. We use the rate of change of frequency. If the relay, if the rate of change of frequency is very high, that relay would operate and disconnect that load from the grid. And once this load will be once this generator would be disconnected due to the variation of rate of change of frequency, again another disturbances would be created, and a cascading effect, total grid failure may occur, because with the penetration of the renewable energy, our system has become very much sensitive to the frequency stability as well as the voltage stability. So conventional protective device which we normally use for the protection of our traditional grid is not enough. We must have to some advanced intelligent protection scheme to protect our grid, to avoid blackouts, and to maintain stability of the grid. And we must have to be aware of the situation, what is happening, because not only that, because the renewable penetration not only makes the inertia of the system lower, making the system sensitive to the frequency and the voltage stability. At the same time, the generation of the renewable energy is very much variable over the day, over the time. So this variation of the variation in the generating system will create lots of stability issues in the grid. So how to handle, how to tackle this stability issues with the help of IoT or the sensor in the power system? My next discussion would be based on this, how to tackle these issues and how this energy informatics can play a great role to make the system much more stable and give the control room personnel awareness about the real-time situational awareness of the system. So this is here from previous slide, I can show the rate of change of frequency is one of the important parameter. Another important parameter is you all know that from the tangent stability point of view is the load angle. Because phase angle between the phase different load angle is that is the phase angle difference between the two voltage phasors of the power network have always some special interest, because the active power flow is proportional to the sine of that angle, sine delta. So that's why in smart grid aspect, the rate of change of frequency and the load angle, the phase angle plays a very important role. So it is clear, I think, all of you, that with the penetration of large amount of renewable energy, our stability of our power grid is under threat. So to maintain the grid stability, the conventional protective system is not enough. So what can I do for that purpose? This is where the wide area measurement system can play an important role, which is very popularly known as the worms. So let me introduce what is worms and what are the players in the worm system. So the wide area measurement systems is a new idea in the system protection of electrical network spread over a wide geographical area. Conventionally, in the power system protection, we don't think traditional protective device, they work locally. On contrary, the wide area measurement system, it protects the electrical network spread over a wide geographical area. You see, this is the transmission and the distribution system. So the important sensor, very important sensor, and it is the heart of the wide area measurement system. It is known as the phasor measurement unit. Abbreviated form is PMU. It is well known as the PMU. It provides, they are placed, this is the PMU, they are placed in the various parts of the power system. I'm coming into the details in which part of the power system. They are a kind of sensor which provides voltage and current phasor information synchronized with time precision to a common time reference provided by the GPS, Global Positioning System. This is very, very important. This is the GPS. Because when we are talking about the measurement of the phase, you as an electrical engineering student all know that we cannot, when we talk about the phase angle means phasor when we talk about, we must have to be as reference, because phasor means they are always that vector quantity is rotating at a uniform speed. So when we talk about the phase angle difference between the two phasor or the vectors, then there must be some reference. That means we must have to take some reference, that reference level, what is the phase angle of one quantity and what is the phase angle of another quantity, and then we can say that the phase angle difference between these two vectors are some things. That means we must have to some reference. The global positioning system has enabled us to work as that reference. So when we the PMUs which are placed in the various buses to measure the voltage and the current phasor, they are time stamped. And as they are time stamped, that means they are measured in a synchronized condition. So the difference of this phase angle, you can find out. So the PMU is possible. The synchronized phasor measurement is possible only due to this global positioning system. Now, this so the worms is capable of monitoring the stability of the grid online. So I would come next how it is possible. So one important thing from this slide I would like to measurement is that it is measuring the voltage, current, phasor, and the information synchronized with the high precision to a common time reference provided by the global positioning system. So next slide, it is also very important. Previously, what is we have the SCADA system, supervisory control and data acquisition system. So in what way the worm system is different from the SCADA system, and why do we need the worm system? and what are its superior features over the SCADA, and which can enable to prevent maintain the grid stability even if with the penetration of the large scale of renewable energy. In the traditional SCADA system, we normally take the information, take the samples with every 2 to 4 seconds. Whereas in the PMU-based worm system, we are taking sample with with a 10 to 60 sample per seconds, which is much higher than the SCADA system. That's why as we are taking more samples, it is possible to monitor the dynamic or the transient stability of the system. With the SCADA system only we can monitor the steady state system. And SCADA system was only for the local monitoring, but the PME based worm system can monitor the global system. It was not time synchronized. That's why only we can measure the magnitude. We couldn't measure the phase angle of the system. But here it is time synchronized with the GPS, so we can measure the phase angle of the system. So it is only magnitude, but here magnitude or the phase is possible, where the phase plays a very important role for online real-time monitoring of the grid stability. So this is the block diagram of the phasor measurement unit. This is the GPS. You all know that the 24 satellites are there at any place. At least you can get 4 satellites at a time. So this is the GPS receiver, and these are the analog inputs, which after passing through the anti-aliasing filter to eliminating noise, it is fed to the analog to digital converter, and it is to get the timestamp. It is with the GPS server. It is with the phase locked with the GPS server, because at what time we would take the samples, we would take the samples. So this is the sinusoidal voltage or the current phasors. So we would take the samples and we would measure the phasor, the magnitude, the phase angle. Also, we measure the frequency and the rate of change of frequency, because I have mentioned the rate of change of frequency is very important to monitor, because with the penetration of renewable energy, the system inertia has been reduced. So it has a great impact on the rate of change of frequency. So basically, we are measuring the magnitude, the phase angle, frequency, and the rate of change of frequency. So the output of the PMU, we get this, normally we get these 4 quantities. Now, this is, I am showing you the what is the actually data which we get from the phasor measurement unit. This is the magnitude, this is the phase angle, this is a nominal frequency with the variation of frequency is there, and then the rate of change of frequency, and the time tagged is important. So we are placing in the power system, the PMU is placed in a particular buses or substation, where that bus voltage and current, magnitude, phase angle, frequency, rate of change of frequency are collected. These are the PMUs, and they are communicated to the phasor data and a server, phasor data concentrator, with following the communication protocol IC 61850. This is very important communication protocol used for the phasor data sending. And as we have mentioned, if you try to imagine the 60 sample, we are getting 60 samples per seconds. So huge amount of data is generated, and the storage, the data are storage for the analysis purpose. So storage, that's why it is, the PMU data is called the big data. In terabyte order data is generated in a month, even if for a few number of PMUs, and the data are storage for analysis purpose. So these are the PDC, which is very important term, Phasor data concentrator, because we are talking about the data-driven system and the energy informatics, and these data are used for real-time monitoring and the control purpose. So. I just mentioned that how the data are generated in the smart grid system. Now, question is that should we place the PMU at all places of the power system? We shouldn't, because a PMU is still a little bit expensive. So we don't need to place the PMU in all the part of the power system, all the buses of the power system. A few number of PMU, which is also known as the synchrophasor sensors, are placed in the grid, and they are placed in the optimum location. What do you mean by the optimum location? Optimum locations is the locations of the grid, so that the entire system is observable. We must say, suppose we have a 9-bus system, for example. I would place 3 PMU in the 9-bus system. So where I would place? We have to place in those 3 buses from where the system is observable. So placing a PMU plays a very important role. Lots of works are going on. Research work is going on in the area of PMU placement, and correct placement is very important for collecting the information. Now, I would like to show some snapshots of PMU data. It has been recorded. This is the angle, phase angle, how the phase angles are recorded over the time for the various PMU. This blue line is indicating in this line some fault were occurred. And this is the variation of the frequency. So this is some real-time recorded PMU data taken from some references. And here I am also showing some data captured by the PMUs. This is, you can see that this is the voltage magnitude. This is for the PMU data. Now you can see the bus voltage, all the bus voltages almost maintaining 1 per unit. But for the orange one, for the PMU 9, the bus voltage has been dipped, sagged. That means in that instant, there is some fault, some disturbances where there are that you can monitor through this PMU data. Here in the right-hand side figure, some interesting thing I would like to, it is a real-time data recorded by Poshoko in 2010 in India. Rihan in Northern Grid failure was there. They have recorded that this blue line is indicating the rate of change of frequency, df by dt. And this is the instant of tripping. At this tripping, at the instant of tripping, you see what is the fluctuation of df by dt. So actually the signals or the data captured by the PMU, we can consider it as the episodes of a serial. And by analyzing the pattern of this data obtained from the PMU, we can identify the health of the grid, stability of the grid, present situation of the grid, whether any, and we can take some actions. But how to take that actions? Because collecting of data alone is useless unless and otherwise the informations are extracted from the big data set. Data mining has already used in various applications of the power system, but in the in this context, in this big data of energy management system, we really need some efficient and effective algorithm which can deal with the large influx of the data. So we need some innovative machine learning approaches that would unveil the great insights and provide valuable knowledge for the system operation. And finally, instead of complex analytical model, pattern recognition based self-synthesized features and the time series prediction would be the key to overcome the challenges imposed by the smart grid related big data. So, what are the tools and techniques that are used? What are the tools and techniques that are used? As I have already mentioned, the big data are the complex, large data set. Physical modeling of this data is not possible because the correlations of the data is not known to us. Hence, the classical computing tool cannot be able to handle this adaptive and stochastic big data of the energy management system. It demands some computational intelligence techniques. That means some artificial intelligence and machine learning based algorithms. So, what are the machine learning algorithms that we can use? Normally, I think many of you may be aware of the various machine learning algorithms. The machine learning algorithms means it can build model from the data itself without knowing the physical insights of the system, and which is really needed for the big data of the energy management system. Now the question is which model we would select for building for the big data analysis of this energy management system. There are basically two types of modeling approach. One is shallow learning model, another is deep learning model. I have just simply comparison for your benefit is that in case of shallow learning model, that is conventional multi-layer perceptron or neural networks, support vector machine, K-means clustering, decision tree, random forest, they request less training data, less training time, computation cost is low. Normally, they have less than 3 number of layers. But thing is that in this figure you can see that the conventional shallow learning model, they cannot learn the large amount of data. They cannot extract information fully for the huge amount of data, which is particularly needed in this case. Whereas another successful and most important machine learning model is the deep learning model, where though we need a huge data, high training time, computation cost is high. Normally, it has more than 3 layers. It is very much suitable for modeling, for analyze or extract information, for prediction by analyzing the big data like which we are getting in this energy management system. So I just want to use 1 or 2 slides to give you just an idea about what is deep learning. Among the deep learning, I particularly give you the emphasis on the convolutional neural network, which is very, very important network structure and can be extensively used for the various applications in the smart grid data analysis. The main advantages, the main difference of the deep learning from the shallow conventional or the traditional learning technique is that it here we do not describe any kind of features to the system. Particularly, if I ask you, you all are aware with, I generally love to give this example as give the example. If I ask you, how can you differentiate a sine wave and a triangular wave? What feature would help you to differentiate the sine wave and the triangular wave? Definitely not if their frequency is same and the peak value is same. The form factor is the features which would help you to distinguish between the sine wave and the triangular wave. So this is the feature, mathematically, statistical features which would help you to distinguish these two waveforms. But a person who doesn't know this form factor, never heard this term form factor, if you ask him, he would also able to, by visualizing these two waveform, he would be able to distinguish the sine wave and the triangular wave. So how it is doing? Because something is going on in our brain, that is the pattern recognition problem, pattern recognition, pattern classification, that without going any particular features, we are able to distinguish the various kinds of pattern, which we cannot, normally we do not do it with help of any particular or the mathematical features. So the main difference between the convolutional neural network and normal traditional neural network is that the feature extraction part, rest of the part is same as a neural network. For feature extraction part, we use various convolution filter, ReLU, activation function and pooling. And in this way, we successively place these kinds of convolution, ReLU, transfer function and the pooling. So in this way, from an image or the signal, we can extract features. These features are not man-made, or we do not describe anything about these features. The features are collected, are extracted from the input image or input signal. Rather, we can say input data itself. So that's why it can extract much better feature than we can we describe it. So these are the major advantage of convolutional neural network and extensively used for this purpose. So this is the mathematical convolution operations which I am showing, that how the features are extract, the convolved features, and convolved features, how they are converted to the pooled feature. As the time is limited, I am not going into the detail of it, but it's a very interesting mathematical operations involved with it. So these are the actually model building process, the input data we have given optimized process, stochastic gradient based optimized process is going on, and the model is building. Another important deep learning model which is used, you may have heard the name, that time series prediction purpose, that is long short-term memory. That when you are feeding, particularly this long short-term memory is used for the prediction. I was talking about the smart meter data analysis for the load forecasting. So it is extensively used for the stock market prediction also. Similarly, for smart meter data analysis, when we have this time series data is there, we can use this kind of deep learning architecture, which is known as, which has some capacity to eliminate the information which is not useful for this particular prediction purpose, but it memorize the useful information and give the output. So here I am just showing the sequence of layer, how you put the input data. It may be the smart meter data or other data, and you would fit, and then you would fully connected layer for the, this is for the regression, the output layer. The time series analysis, it is referred to the analysis of change in the trend of data over a period of time. Time series analysis have a variety of application. One such application is prediction of the future value of an item based on its past value. The load forecasting using smart meter data analysis is a typical application in smart energy management system. Here I am just trying to show with the big data application of the various big data applications of the energy management system. It may be wide area situational awareness, state estimation, power and event classification, short-term load forecasting, big data driven demand response is possible, system security and protection. So these are the areas. This is a schematic representation that dynamically changing energy system with large share of renewable energy equipped with the IoT. IoT is nothing but some sensor with the communication through the internet. So we have the smart meter and other sensors, and from where we get the data, and these data would be analyzed to the optimization, machine learning, and data mining for taking the various control strategies and real-time applications. And these are the various applications area we can work. And now we are talking about the data computation and algorithm. But keep in mind, when we energy management system data, they are a huge big data. Normal computer is not enough for analyze this data. Even if you have the GPU, graphics card processing unit, you would not be able to compute these deep learning based algorithms. Normally, the utilities, those who have the smart meter in the various parts of the power system, they deployed the cloud computing. They now various service providers are there. They you can the utilities can hire this cloud. It is nothing but a huge computing system through internet. The data are fed to the cloud, means it's basically computing the IBM, Google. They have the cloud. Cloud means the computing platform. Huge data can be analyzed with with a very small time, because when we are talking about the power system data, and also we are talking about the real-time monitoring, you have to keep in mind in the constraint of time, because this transient stability is within a range of 10 milliseconds. So within this, we have to take all this decision 100 millisecond, that means the 5 cycles. So we have to take all this crucial decision within these 5 cycles. So whatever algorithm, whatever data algorithm and computation you have to take the decision within a 5 cycle durations, maybe much faster. The computing platform is very important. I would like to, I am end of my presentation almost. Some algorithms and their applications here I am mentioning. The load classifications, estimation of solar power prediction. Solar power prediction is also very important field, because for management of power, you have to, from forecasting data, you must know that what would be the available solar energy or the wind energy based on the weather data you can estimate, and they have used k-means clustering algorithm, some decision tree random forest for fall detection and classification is possible. And adenine and a smart meter analysis, you can use a long short-term memory recurring neural network. And rotor angle monitoring, deep learning neural network has been already used in the literature. So here I am just want to show you some schematic representation of PMU based control and monitoring. So this is our power system. Some power system continuously some disturbance may occur. So in the power system optimal places, the PMU are synchronized, are placed. We are getting some synchronized phasor measurement data, and data are fed to the decision processing system, where we can use the various algorithm. That may be the deep learning based algorithm, whatever the algorithm, where this input data, the big data, they are transformed into some actionable decision, and this decision is fed to the power system and making our system self-healing. That is one of the important feature of the modern power system and smart grid environment, so that we can isolate the healthy part of the power system from the faulty one immediately before the grid collapse. Because this is very, very important when the power system is integrated with a large amount of renewable energy. So I have tried to give you some message that the energy informatics is very, very important. It plays the data analysis algorithm is making a paradigm shift in the power system. And this is the future of the power system. Lots of jobs are there in this area because the power system would grow in this area. The energy informatics is becoming a very, very important issues, basically, which is the digital twinning of energy and AI, artificial intelligence, and with the big data analysis of the energy management system. So finally, I am showing that how we can use it. Say these are some pattern. This is for various grid events, generator trip and load shedding. Load shedding. This is some oscillation going on, and this is the pattern of the signal of the load angle. I have taken it from a literature. And these patterns are fed to the deep learning based architecture for classification of various grid event. And they have demonstrated that it can easily be distinguished the various grid events using the PMU data. So lots of researches are going on. Our group is also working in this area extensively. So what are the future challenges and future scope? Definitely, as you understand, it is a multi-source data integration and storage, because we are getting from the various sensors, and real-time data processing and technology is important, because otherwise we would not monitor data compression, big data visualization technology, which technology we use, and developing better sensors, pairing with big data analytics to create actionable information. Data privacy and data security is very, very important in this regard. Otherwise, if it is not maintained, everything would be jeopardized. So lots of work can be done. You can take as your project or the research project, you can submit. Lots of opportunities are there. Our group is also working, my research scholars are working in this area. So these are the reference which I have taken help for preparing this presentation. Thank you all.
Thank you, madam. We really enjoyed the session and gathered lot of knowledge on this domain.
Thank you.
I have we have one question, so I would like to ask you that.
Yes.
Yes, there's one question. Uh, how penetration of RS decrease the total inertia?
Okay. So, okay. This is a very important issue, and this is let me explain. Go to the slides. Now you come. I think this equation you have seen that the H is total system inertia. In inertia means actual inertia. H means the J actual inertia into the capacity of invert. So when we are taking the summation of H1 plus H2 plus H3 and Hn, that means it is the inertia of the traditional fossil fuel plus the renewable energy. Now, in case of renewable energy, the J value is very low because the traditional fossil fuel, this inertia is very high because it has a physical mass, whereas the renewable energy, the physical mass, physical inertia is very low. That's why when we are penetrating large amount of renewable energy, the inertia is becoming, effective inertia of the system is becoming very low.
কথা বলছেন, আমি তো কোশ্চেন আনসার করলাম, একটা কোশ্চেন
Hello.
Hello,
Please,
hi.
sorry for the interruption, madam. Please
Hi.
unmute Kamalika, madam. Sorry, mute. Sorry, please mute. Okay. Yes, madam. Please continue. I have just joined, madam. I was initially in the meeting. So, madam, so I could not hear half an hour a part of a session is so interesting. Anyway, so madam, please continue.
Yeah, so the question was that, and this is the very important issue in integration of the renewable energy, because what system has become very, very sensitive to the frequency as the inertia is reducing, because the fossil fuel, because in traditional power generated, physical inertia is very high. You see, here I have symbolically represent the inertia. If the inertia of the system is very high, even if there is a large gap between the generation and demand, there is a very little change in the frequency. But if the inertia of the system is very low, if there is a gap, small difference between the generation and the demand, this deviation of the frequency would be large, because the renewable energy itself has a very, very low physical inertia. Any question?
Is there any other question, madam?
No, madam.
Kamalika, madam, is there any
No,
other
madam. No,
question?
madam. Only one question.
I have a question. I have a question.
Yes.
Yes, sir. Yes, sir.
Yes.
I would request Paramita madam to
Yes.
To elaborate on the need for phasor measurement in a large integrated grid. Why the need for phasor measurement becomes very sensitive?
Very. Thank you. Very, very important question. Very important question. So, as I mentioned, so it is coming in consequence with the sensitivity of the frequency, because as I mentioned, integration of renewable energy making the grid very sensitive to the voltage and the frequency stability issues. And why? Because the inertia of the renewable system is less. Now, conventionally, for protection of power system, we use the conventional protective device like distance protection. But this distance protection we use the locally, it is not enough to monitor the total situation or the power system in the presence of renewable energy. Because in this situation, this as the system inertia is reducing, the system is very much sensitive to the frequency. That is, df by dt is very high. What would be the problem if the df by dt is very high? If the df by dt is very high, then what would happen in the system? We have already installed some protection rate of change of frequency protection. So if it is very high, that rate of change of frequency relay would operate. As it operates, it would disconnect that power supply from the grid. So once it would disconnect the power supply from the grid, again another disturbances would be created. So in this way, a cascading failure would occur and the total grid would be collapsed. So conventional power system protection would not be able to monitor these sensitive issues. So that's why we need the phasor measurement unit where we use the PMU. PMU particularly measures it monitors not only the magnitude of the frequency, it also monitors the rate of change of frequency. Because this rate of change of frequency, the pattern of the rate of change of frequency is different from the various disturbances that occurs inside the power system. And by pattern recognition problem, we can identify just simply by monitoring the rate of change of frequency, what kind of disturbances has going to occur inside within the power system. And that's why we would get an overall idea about the power system. So in this slide, I have tried to emphasize the entire grid over a vast geographical area. We have not placed the PMU in all the buses. We have placed it in few places. And we have taken the data from it. What data we are taking? We are taking the rate of change of frequency, which is very sensitive, to indicate what kind of disturbance is going to occur. So by monitoring, now we are collecting this data from the various PMU, and these data are stored in the phasor data concentrator. And now with the data analytics or the machine learning techniques, we are analyzing this data. And by observing the pattern of this PMU data, where the rate of change of frequency is also an important part and the phase angle is also an important part, we'll come to the conclusions what type of disturbance, what is the state of the power system, whether in a stable state or marginally stable state or dynamically stable or the transient stability condition, what actions we should take. That's why the wide area measurement is becoming very, very important. Though I should mention it is the positive side, but the PMU is a little bit expensive, though its cost is reducing now. That's why we do not place the PMU in all the places of the power system. We use a very few number of PMUs, and we collect the data. And we have at present very powerful data analytics and computational techniques, which is enabled to extract the hidden information from those data and to give information, knowledge extraction about the grid stability. That's why the wide area measurement is becoming so important nowadays.
Yeah. Thank you, madam.
Thank you. Any question? Okay,
No, madam.
thank you.
Madam, just wait. I will be presenting the certificate. Madam is there? Our HOD madam? Okay, wait. Wait, madam. I'm just presenting the certificate.
Okay. No problem, no issue.
Yes, madam. Just there's a net issue.
Yeah, no problem.
প্রেজেন্টটা কোথায় করবো বলুন তো? প্রেজেন্টটা কোথায় করবো? সেটিংসে? Madam, is it coming? No.
Not yet.
Share.
Yes, thank you very much.
Is it coming? It just come, madam?
Yeah.
Yes.
Thank you very much.
Thank you, madam.
Thank you.
Thank you, madam, for your support and for sharing your time with us. Without this program would not have been possible.
No, it's my pleasure.
And madam, I will mail you this certificate. Okay, and I hope that will be with us in the future programs because there are 2 more phases of STTP. So I would look forward. Yes, sir. We would look forward to you, madam. Okay.
Yes. Okay, thank you very much.
Welcome, madam. So good day. Okay. So thank you to all the participants. Thank you, sir. And thank you to all the session coordinators. To the participants, I would like to say we'll meet again. At 1:55, the break time is pretty short today, but actually the hands-on will start from 1:55 p.m. There is another hands-on demonstration in the second half by Professor Shushanto Ray. Okay, so please be with us, though the time is short. Please join us. Okay, so good day to all.
Good afternoon, ma'am. Good afternoon, sir.
Good afternoon. Am I audible?
Yes, sir. You are audible. Sir, kindly wait for
Let's
few
start.
minutes.
Okay.
Sir, kindly wait for few minutes. Okay.
Okay. I'm ready.
Hello. Good afternoon, everyone. Hello. Can I hear me? Hello. Hi. Hello. Hello. Good afternoon,
Hello.
everyone.
Good afternoon.
Welcome to sir. Welcome to our STTP. This is the second day for the hands-on, and welcome to sir. And I would like to request sir, please take over the session, and the session is yours. Thank you, sir.
Okay. Thank you. So, I'm just starting my presentation. So, am I clearly audible there?
Yes, sir.
Yes, sir, you are audible. You can start, sir, now.
Okay. So, is the screen? You can see the screen.
Yes, sir.
Some PPT presentation. Can you see?
Yes,
Yes,
sir.
sir.
Okay. So, welcome all. So, today also I'll be discussing some experimentation using Arduino Uno, as we have already discussed in our last class. So, how the program for Arduino Uno can be written in Arduino IDE using the C type language. So, yesterday we saw different programs for two types of module, basically parallel communication using the digital IO pins and serial communication. Okay. Now, in parallel communication, that means using the digital IO pins, we wrote some program to glow the LED and also how to blink the LED in a uh, in a constant frequency, and how to blow the LED, how to blink the LED in a changing frequency. We wrote some programs for that. In the second half, yesterday we wrote some programs for our serial communication. There we wrote some program for only reading the uh, data sent from the Arduino into the computer. Then we wrote some program for both reading and writing. That means reading from the Arduino and writing to the Arduino. Then some A to D conversion program we wrote, and the output we were trying to show in the serial monitor. So that means we used the serial monitor as one of our output device in yesterday's class. But today we will learn a different output device, a very common one, that is an LCD module. So LCD means liquid crystal display. So LCD module can be used as an output display, and we can show our output very uh, clear way. So let us start with the LCD. Okay, so this is a very common LCD module which is available in the market and which is used along with any Arduino board or any microcontroller board. This is called 16 cross 2 LCD module, where there are 2 rows and 16 character can be shown in each row. So that is called 16 cross 2 LCD module. Now here I have shown the pin out diagrams of the module. Uh, as you can see here, there are 16 pins. So the important pins are that is required for controlling the LCD module is basically highlighted in the gray colors. In the gray color, you see the pins are register select, or in short form we call it RS. In short form we call it RS. That means the register select. Okay. The next important control pin is read write. Basically, is the read write bar. That means when we'll write something, we have to keep this pin at logical low level. Then we can write something. That means if we ground this, that means we are writing something to the register of this particular LCD module. And the third control pin is enable. Okay, so to write something, we must enable the LCD module. So these are the 3 important control pins of the LCD module. Now there are 8 data pins. Okay, so 8 data pins are there starting from 0 to 7, and the pin numbers are from 7 to 14. Now there are 2 modes for writing data to the LCD module. Either we can write in 4-bit mode or 8-bit mode. Okay, so if we use the 4-bit mode, then the other 4 pins will not be used. Only 4 pins will be used. Okay, now this LCD module has a backlight, and that backlight comes from a bright LED. Okay, so the LCD has a backlight, and the backlight is coming from an LED. So this LED also needs 2 pins, one LED positive, another LED negative. And the very common 3 pins are VSS, which is ground, VDD, which is the positive voltage for any device, any electronic device. We need some ground and positive voltage. So these 2 pins are marked with black and red, and a V is a constant voltage. Okay, so this is a pin out diagram of 16 cross 2 LCD module. Now I have already discussed this. Basically, as you have seen already in the previous slide, that it has 8 data pins. So therefore, the LCDs have a parallel interface. That means we can write the data parallelly. Okay, so the communication with the microcontroller should be a parallel communication. It should not be a serial communication, because we have 8 data pins. So then for controlling it, we have register select RS pin, which controls the LCD's memory, where we have to write the data. Okay, so you can select either data register or you can select the instruction register. So when you will select the data register, then the data will be written in the data register of the LCD module. So LCD module has its own registers like data registers and instruction registers. So by this register select pin, we can either select the data register or the instruction register. Before selecting the data register, first we have to select the instruction register. Remember, okay? Now, this is the general discussion of LCD. Now, other things we have already pointed out. One is the read-write pin, which should be kept low for writing mode, and reading modes that should be on. Generally, we use for writing. Generally, we use the LCD panel for output device. So therefore, we keep this read-write pin low to write something in the data register of the LCD. And enable pin also you have to keep high to enable the LCD module. Data pins are D0 from D0 to D7. I have already pointed out that, and all these things I have already discussed in the previous slides. Now the LCD shield. Just after this slide, I will show you the LCD shield. The LCD module, which I have already shown in the previous slide, it sometimes comes with the LCD shield. LCD shield is nothing but another board which is compatible for Arduino board. Okay, so we don't have to connect manually by the wires with the LCD and the Arduino board. It can be attached with the Arduino board directly. So I will show this video. Now, when we are using this LCD shield, so the common instruction which we use for LCD declaration in our program is called the liquid crystal. That is a typical data type liquid crystal defined in some library of LCD. So the liquid crystal is the data type and the variable name is LCD. It has 6 arguments. What are the 6 arguments? 2 arguments are for control, that means RS and EN. So we have to mention which pin of this LCD shield I have connected with Arduino. If I have connected suppose if I have connected the first pin, that means the 0th pin of Arduino to this RS pin of the LCD shield, then I have to write here 0. If I have connected the third pin, that means the your the D0 pin of this Arduino, sorry, D2 pin of the Arduino, so I have to write 2 over here. And these are for the data registers, and you can see here we are using only 4-bit mode data transfer, 4-bit mode data writing. So only therefore only we have used only 4 data pins. So these are the pins of the Arduino through to which the D4, D5, D6, and D7 pin of the LCD module or LCD shield is connected. Okay, and these connections are already done. If you connect this LCD shield properly with uh, this Arduino, this will be already connected. So let us see how it can be connected. So this is a LCD shield. You see, this the top portion is basically our LCD module, and it is mounted on a board which is called the LCD keypad shield. Okay, so there are some connections with this LCD module, basic LCD module, and the board which is called the LCD shield. Okay, the board has other features. It has some pinouts, it has some keys over there, written right, left, up, down, select, etc. That means the LCD shield may have some additional features. So these are the data pins as I already shown in the PowerPoint slide. These are the pins and these are few buttons. So this is the back side of the shield. This is the back side of the shield. And you just see how we can connect this with our, so that means this LCD shield can be directly mount up on our Arduino board like this. So that means here the connection is very simple. Okay. So this is how we can connect the LCD shield with the Arduino board. And thereafter we have to connect with our PC. So this is the video which will show you how to connect the LCD panel or LCD shield with our Arduino board. So let us start some program. So this program I have written to display a simple string on the LCD panel. So this is the program. You can see this is a simple program on LCD. Now first we have to include the header where the LCD related functions have been declared. And that header is called the liquid digital.h. L is capital and C is capital. So include liquid crystal.h. You have to include the header first. Then, as we have already mentioned in the earlier slide, that we have to declare a variable LCD. This name can be anything because that is this is we are declaring as liquid crystal type variable. So our data type is here liquid crystal. So liquid crystal type data variable is small LCD, which has uh, how many arguments? 4 arguments. So as I mentioned, these 2 are the control pins and these 4 are the data pins. So that means here, if we go back to the earlier slide, you see the RS pin. So the RS pin of the LCD shield is connected with the 8th pin of, that means this your Arduino board. You are connecting 8. 8 means D7. D7 is our 8, and this is your D8. Okay, isn't it? Okay, 8 means, I think 8 means D8, 9 means your digital IO pin 9, and these are the digital IO pin 4, 5, 6, and 7. Okay, so these are the digital IO pins of the Arduino with which your RS, EN, D4, D5, D6, D7, these pins are directly connected. Okay, so that is RS of the LCD shield is connected with the D8 pin of the Arduino. The EN pin of the LCD shield is connected with the D9 pin of the Arduino, and these 4 pins are connected with the D4, D5, D6, D7 of the LCD shield. So this is how we are configuring our LCD variable. Now, in the setup function, we have to write these sets of lines. First one, we have to write lcd.begin 16,2. So that means lcd.begin is a function which is defined in the liquid crystal header, which tells Arduino to send some set of instructions to the LCD module to start it, to begin it. Okay. Now, the second is the LCD set cursor. LCD set cursor is the location of the cursor where the following string will be written. So what is the string to be written? That is the intro Arduino. Okay. So lcd.print, so it will write the intro Arduino in the data register of the LCD module. So the intro Arduino will be written in the data register of the Arduino, and actually it will be written on the display by the data register of the LCD panel. Okay. Now this one is the second line. The second line 1 and spaces 3. Okay, so let us see when this program is written on the Arduino, how it will show it on the LCD. So let us compile it. The same program I have written here. Okay, so let us write some other text so that it's not connected with the board. Okay. So let us write it. and let us play the video. Okay, so this is the, let us start from the beginning. So when I will write this program in Arduino, it will show the display. So the string on the display, intro Arduino, normalized to dot technology. And suppose if I change it in the previous string, then in the next program written on the Arduino, how the display will be changed, you just observe. You just watch on it. So the next string is coming. So this is how it has been changed with the next device string, that is intro Arduino, how it is. Okay, so this is how the program is done with LCD. Next, so that means we have learned a very basic program with the LCD. Now we'll start with the another program with LCD where we'll write a string. Let us see which program is there. Okay, so that means come to this. So this is our the first program where we are writing only a few strings like intro Arduino, how it is, or intro Arduino, normalized to technology, like that. Now, in the second program, we'll print some text on LCD from right to left, and it will be a moving text. Now, here also, the initial portion of the program will remain same. That means include liquid crystal.h, the header inclusion. Next, the variable data type LCD, liquid crystal type LCD, and the pin configurations are given in the argument. Now here we'll start a character with A. So that means int this character. So this character is a variable which is integer type and it is equals to A. And I will print this. So here LCD begin, LCD cursor is there. So all this program we have already written in our previous setup program also. Now here the change is how to control the display of this character. So that means if we go to the next part of this is the first part of the program. This is the next part of the program. What it will do actually is written here. Okay, so it will write. So forget about the first part or this part. I will discuss it later. But you see this portion of the code. This portion of the code which is let us okay. So this part of the code is most important thing. That means LCD dot write this character. Now this character, initially this character will be A. As I declared, this character as A at the beginning. Then this character will be increased. So that means as this character is an integer, so it will take its next value. So as the next value is B, so end the loop and it will rotate in the loop, because the loop function is basically an infinite loop. So in the next loop, it will write again, it will come here and it will write B. Then again it will be increased, and in the next loop it will write C. Okay, so that means first it will write A, then it will write B, then it will write C. But if it writes like this, where I have to control this moving text. So those part of the controlling is declared or written here. So that means here it is saying that if the character becomes M, with this advancement of character, if this character becomes M, then the LCD dot right to left. That means first it will start writing from left to right. When the character becomes M, it will start writing from right to left. Okay, so generally how we write? We write generally left to right. Okay, so initially also it will start with A, then B, then C, D, E. So left to right, it will start writing and the character will move. Okay, but when the character will be M, then it will stop writing from left to right and it will start writing from right to left. So therefore this function is given here. That means when the character becomes M, this will start writing from right to left. Okay, again when the character is S, again it will start writing. Okay, so here you see, if the character is S, go to the next page, it will again start from left to right. So there will be some toggling from left to right and right to left. Okay, so let us compile it. Okay, so let us see this video. It's not this one. Let us. Okay. I think the previous video only. Why here that? Okay. So this program is written like the writing like this, and you see, up to this it was the previous program. Then I'm writing this, and you just see how the characters is written. You see when the M will we are writing in the LCD panel is pin to analog. Now LCD set cursor. So after writing it, we are moving to the next row where the actual value will show. In the next row, we are writing some value that is also a simple string. It will not change. It's a constant string, the value. So value is a basically string. It is not the value. The value is the converted value which will write in the second part of the program. So this is the second part of the program. That is the loop function where we have declared LCD dots set cursor 7, 1 because you see here we have written LCD 0, 1. That means 1, 2, 3, 4, 5, 6. So that means 6 character we have already taken to write the value string, value colon string. Okay. So in the second row, we have already occupied the first 6 character for writing the value colon string. So therefore, when we are writing the actual value, actual converted value from analog to digital converted value, when we are writing the actual converted value, we are selecting the 7th character. Okay. Then this portion of the program is similar to the previous day's program. That means here the in pin is the A2 pin where I will give some analog data, and this analog read function will convert that analog data at pin number 2. And when this conversion will be completed, that will be stored in a variable called ADC underscore E underscore in. Okay. So that means this in pin is our A2 pin, and whatever analog data will come to this A2 pin will be converted to digital by using this function analog read, and it will be stored in an integer variable called ADC underscore E underscore in. Okay, is that clear? So next, what it will do? It will write this. Okay, if there is some previous value, first it will erase that, because the problem of LCD, if you don't erase that, it may so happen that previous value may remain there. Suppose the previous value is suppose 1024, and the current value suppose 53. Okay, so if we don't erase all the previous characters, so now if my character if my now the string is 53, so it will write 5324. So that 24 of 1024 will remain. Okay, so therefore it's a very good practice when you are writing some variable which is getting changed. Before that, you just erase the previous values. Okay, so you just erase the previous values with some blank string like this. You just see how many strings are there previously. You just make it clear. Then you write your new string. Okay. Then you write your new string. What is the ADC underscore key underscore in? Okay. So here, this is how you are writing your digitally converted data from analog data in your LCD panel. Similar thing you are also writing in your serial monitor So that means you are sending the data serially from Arduino to your PC. And in your PC, when we'll open your serial monitor, either from the Arduino ID or different serial third-party serial monitors are available. You can search over internet. So what is the data in your PC, in your computer, in your laptop? You can see by some other serial monitors also. Here we have in Arduino IDE, we have a feature of serial monitor. So here just by clicking the serial monitor, we can see whatever the serial data is coming. Okay. So this is how we are getting the data in LCD panel as well as in the serial monitor. So let us first which program. So this is the program. Okay, so let us see what it will give. So here it is getting executed. So here we have, okay, so when we are grounding that A2 pin, it is showing very low value, is 0. And when we are changing the voltage at A2 pin, it is changing the digitally converted data. Okay. You see how we are changing the data. Some garbage data also it was showing basically. Now I have connected with the plus VCC pin, which is showing around 1000. It's not, it should be 1024, but as the voltage is not constant, so it is showing around 1000 only. And when I am connecting with the ground, it is showing 0 or the value near to the 0. When I am connecting in again in plus VCC, it is showing around 1000. And when I am connecting in plus 3 volt, so because just beside the plus 5 volt, you have plus 3 volt. So there it is showing around 646 well. Again, I am connecting to ground, it is showing 0 or the value near to 0. Okay, so this value you can also see in your serial monitor. Okay, so this is how we can write our different programs for LCD display. LCD display is very common display and very easy to understand display. We can use with our embedded system. Okay. Now, the next thing which I will show you, I don't know whether I will get time or not. So let us start with the next program. I will skip and I will go directly to some ultrasonic sensor. Okay. So ultrasonic sensor also I have to go very first. So I have before that I will show you some ultrasonic sensor. Then I will start discussing with it. This is an ultrasonic sensor. It's very common, used with Arduino, and it has 4 pins, pin out, which can be connected with your Arduino board. So the 4 pins are, as you can see here, the plus VCC, TRIG, that means triggering pin, TCHO echo pin, because for this One is transmitter as given by T, another is receiver. Okay, because ultrasonic sensor transmit some signal and it receives that signal and it calculate the time. By that time, it measures the distance. That is the basic technology that you all also know. So therefore, we need two things here. One, it will be triggered. Another, the echo signal will be taken by this pin. So this trigger pin and echo pin, and two other common pins, VCC and ground. So that means this is your I say SR04 HCSR04. The module here is HCSR04. You can write down this. It's an ultrasonic ranging module. Provides the specification of HCSR04, which provides 2 centimeter to 400 centimeter non-contact measurement function. That means in non-contact way you can measure some distance. Okay, so it has transmitters, receivers, and the control unit. The basic principle of our work is using the IO trigger of at least 20 microsecond high level signals. Okay, the module automatically sends 840 kilohertz detect whether there is a pulse signal back. Okay, if the signal is back to the high level, time of high output IO duration is the time from sending ultrasonic to the returning. So this is how the distance is calculated. So high level time into the velocity of sound, as you know, 340 meter per second divided by 2. So here I should use one more bracket. So that is the formula by which you can calculate the distance. These are the connections as you have already seen. Okay, that is the 4 pins are there in your ultrasonic module. One is plus 5 volt trigger, echo pulse. Echo pulse is basically input for this your module, but here it is echo pulse output is given. Okay, and that is the timing diagram as I already mentioned in the earlier slide. There will be some high low frequency signal and some 40 kilohertz signal. Okay, so this is how it is measured. Okay, so let me so this I have already seen. This is the crystal oscillator which generates the high frequency signals, and here we'll connect with the 4 different cables. The red cable we'll use for the plus VCC, and the green cable will be used for ground. The gray cable will use for trigger, and the yellow cable will use for echo. Okay, so that means this red cable will connect with our plus 5 volt of Arduino board, the green cable, green wire will connect with the ground of the Arduino board. And suppose if we use digital IO pin 2 for echo, then this yellow cable, yellow wire will be connected with digital IO pin 2. And if we use our digital IO pin 3 for trigger, then we'll connect this brown wire, brown cable to digital IO pin 3. So this is how these 4 wires will be connected with our Arduino board. So let us see how the module is connected. Okay, so here the problem is, if we use the LCD module for displaying the distance measured by the ultrasonic sensor, we cannot access all the pins of the Arduino board, as the LCD shield has already been mounted on the Arduino board. So that means some of the pins are hidden behind the LCD shield, or are used, some pins are being used by the LCD shield itself. Okay, so only you see only some empty pins, empty digital pins, IO pins are available here, starting from D0, D1, D2, D3, D4, D5, D6. So only these pins are available. Okay, so we can use, as I mentioned in the earlier discussion, we can use this digital IO pin 2, D2 for our echo and D3 for trigger. Okay, and this pin we'll use for ground, and this is plus VCC. This is our plus VCC, plus 5 volt, as is written there, plus 5 volt. Okay, and this is your ground. Okay, so this is the red where plus VCC is connected to 5 volt. This is the green where the ground is connected to ground. This is the trigger connected to D3, and this is the echo which is connected to D2. So this is how 4 wire coming from your ultrasonic sensor will be connected with your LCD shield, and LCD shield is already connected, already mounted on the Arduino board. So that means through this LCD shield, these 4 wires from the ultrasonic sensor is getting connected with the Arduino board actually. Okay, and this is the this thing. So now we have to go for our program. Okay, so it is not visible. I think I have to use my PPT. So do with ultrasonic sensor. So the sensor is basically our so these are only for commenting these lines will not execute. As you know, this I have written for understanding the program. This is for the command lines. As we are using SR04 ping distance sensor, so I have written the name of that. Now the VCC of this, so here I have defined the connection. So VCC of this ultrasound sensor has been connected with plus 5 volt of my Arduino board. The ground is connected to Arduino ground. The echo pin has been connected with pin number 2 of Arduino, and trigger pin of the ultrasonic sensor has been connected with the digital IO pin number 3. So that I have declared here to for understanding the program. Now this part of the program for this LCD, so include liquid crystal.h, and some variable I have defined, or rather constant you can say. These are not variable, these are constant. So define echo pin 2. So that means echo pin is defined with a value of 2, trigger pin is a value of 3, and LED pin is value of 13, though the LED pin will not be required in this case. Now liquid crystal LCD, another this important declaration for LCD module. Now here, both though the maximum range is 400 centimeter, so I have declared only 7 because here to create 400 centimeter is difficult for the video. So I have taken the maximum range is 70 only, and the minimum range is 5 to keep safe side. Okay. So other variables I have defined as a long variable, long data type variable with duration and distance. Okay, so duration and distance I have declared as a long type data type, and frequency as integer data type. The next part of the program where the setup function is declared. In the setup function, what I have declared, the trigger pins means the which pin, D3 pin of Arduino is declared as output, because from Arduino some triggering pulse should be sent to the ultrasonic sensor. So therefore, that trigger pin or the D3 pin is declared as output. So for that, this line is written pin mode trigger pin output. The second line is the echo pin. The echo pin is basically the D2 pin, and that should be input. Whatever the echo signal will be received, okay, that should come through this D2 pin. So therefore, that is declared as input pin. Now the pin mode LED pin is output, is the pin number 13. It is not required. Now LCD dot begin, again this line is required for this LCD. And LCD dot set cursor 00, that means some string for understanding from the LCD display we should write. So some string I have written, that is the ultrasonic range. What I am measuring? I am measuring basically the range, ultrasonic range. So therefore the string I have written from the first character of the first row, that is the ultrasonic range. Okay. Now, then in the next part of the program, we are arranging the timing. As I have shown the timing diagram of that this ultrasonic module. As per this timing diagram, I have to send a sequence of pulse to this trigger pin. So what is that? First, I am sending some low signal through this trigger pin. For how much time I am sending this low signal? For 2 microseconds. Okay, so these two lines is basically I am sending a low signal for 2 microsecond. I'm sending a high signal for 10 microsecond. Okay. Again, I'm sending some low signal. That means a low, then high for 10, then again low. Okay. Then the pulse declaration, the duration, it will take the duration from the echo pin. So this pulse in is basically will take the duration from this echo pin. How much time the echo pin is kept high. Okay, so that will be taken in the duration. That will be assigned, that will be stored in the variable duration. Now, how the distance is calculated, as I already told you. So there is a conversion. By this conversion, we got this the sound velocity and all. So if we divide the duration by 52.8, we'll get the distance directly. Okay. So that means the distance we can calculate from the duration of the echo pulse. If the duration of the echo pulse is duration, so duration by 58.2 will give you the distance in centimeter. Okay. Now, if the distance is maximum, more than the maximum range, it can be happen, or less than the minimum range. What I'm trying to write, it is range out. That means it cannot be measured. So it will show you range out, and it will show no measurement. So therefore, I am keeping the measurement portion of the character blank. Okay. Else, that means if these extremities don't happen, then it should measure the actual thing. If two extremes, within these extremes, if the range comes, then it should do the actual calculation. Okay. So that is the frequency equals to distance into 50. Okay, so if distance is less than 150, we are writing that in LCD with the distance. Okay, so you see once more. So this is the distance. Again, I am setting another variable because of this limitation of to arrange that much distance during the experiment, distance between the ultrasonic sensor and the obstacles. So I am limiting that distance everywhere. Here also you can write 70 only. Okay. Now it will show the distance. It will show first distance equals to, and the actual value of the distance it will show here. Okay. So this is the program. You can take the snapshot of it. Then I will go for the video. If you have completed, then I will show the video. How it is functioning. So initially there is no obstacle, so that means the obstacle is far away. So therefore it is showing that range out. it is showing the range out because the obstacle is not there, as if the obstacle is far away from this ultrasonic sensor. Now, when I am keeping some obstacle in front of it, you see it is showing some. Well, I'm increasing the distance of the obstacle from this ultrasonic sensor, and the distance between that obstacle and ultrasonic sensor is showing there. Again, I'm reducing it. Okay. Okay, see, it is ranged out. With my hand, I'm making the obstacle. Okay, so just that means in a minimum range, also it is showing the range out. Is that clear? So this is how the ultrasonic sensor will work. Now, if you have any doubt, you can ask me. We are almost at the verge of our completion of this hands-on program. So if you have any doubt, so you can ask.
So participants are requested to put your questions in the YouTube chat box. Sir, thank you very much for this excellent presentation.
Okay. Okay. Thank you.
Till now, there is no question.
Hello, Priyanjali. Do the faculty have any questions? If any faculty has any question, they can ask also, because it has been a hands-on demonstration which is very difficult to present online, but still SARs are trying their best. So if the faculty have any question.
So one more thing I thought to present here, but I don't have that with me. That is a light meter. So yesterday when I was searching for the light meter, I see that I don't have that. So I already
You keep
kept
it
in
for
my
the next phase.
department.
No, you keep it for the next
Huh?
phase. We'll be running 2 more phases of the same HDB. You keep it for the next phase. Okay.
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 I,
Because it's very.
Amita, do you have any question?
No, I don't have it because I could not be present for the entire session. Okay, so I'll have to watch the recorded session. But yes, what I could understand is that it is a very difficult thing to show everything in online. Okay, so anyway, the programs that we have given that will be very helpful for the participants to practice, as well as we can also will forward the programs to the students also, so that they can do also some projects. Okay, both you and Vishendu sir have shown us many layouts of how to do the different kinds of programming, simple programming, and as well as how projects can be done starting from the basic level. So it has been a very enriching experience. And so if there are no more questions, Priyanjali madam.
Yes, ma'am.
So okay,
So, on behalf of the Electrical Engineering Department, I am sharing the certificate of appreciation. Sir, is it visible to you?
It's visible. So thank you very much, Priyanjali. Thank you, Naumita, and thank you all the organizers from NIT. I'm privileged to present an hands-on demo, which is a challenging task because all this hardware-related thing to present in this online platform is not an easy job. So initially we thought for the actual hands-on demo. Afterwards, there is a lockdown, and now the situation is completely different. So we have modified ourselves like this.
Sir, it
Okay,
was
so
an
thank you very
excellent
much.
presentation, and thank you for sharing your valuable time and knowledge with us. Sir, thank you for your contribution
Okay,
to make this session
okay.
successful.
Thank you.
Thank you, sir.
Shushantu, I will mail you the certificate, and we will all look forward to your participation in our future programs. Okay, and to the participants, I need to say one thing, that tomorrow we'll start again at 9:50 a.m. Tomorrow there is only one lecture session. After that, there will be an online examination. So, good day, Shushantu. Thank you.
Thank you. Thank you
Okay.
all. Thank you.
And thank you, Priyanjali madam, and to all
Thank
the
you.
faculty and staff of my department. Thank you to all the. Okay. So, good day. I'm closing the session.